Good morning, Arindam da. You're muted.
Hello, Pallavi. Am I audible?
Yes, you are audible. With your permission, sir, shall we start? Okay, thank you. Namaskar, a very good morning to all the participants. Welcome to the final day of STTP in Econometrics. I, Dr. Pallavi Mukherjee, welcome you all, and I hope you guys had a very nice STTP program. However, this is the final day, and we are accompanied by our eminent resource person, Dr. Arindam Laha, and he is going to take two sessions today, the morning session and the pre-noon session, both the sessions, and his topics are going to be closely related to structural break, definitive, dummy variables, etc. Let me introduce Dr. Laha. Dr. Arindam Laha is head and professor of economics, statistics, and econometrics, Department of Commerce, Bardhaman University, West Bengal, India. Dr. Arindam Laha has been teaching economics at the Department of Commerce, the University of Bardhaman, West Bengal, since the last 10 years. He is gold medalist in post-graduation from the University of Bardhaman and state-funded research fellow. He has written 3 books and published various research articles in internationally reputed journals. Now, wasting no more time, I now give an open dais to Dr. Arindam Laha. So please start the session. We have given you the sharing rights.
Okay, thanks Pallavi for your generous introduction. At the outset, I would like to express my sincere gratitude to the coordinators of the short-term training program for inviting me in this phase 2 of the short-term training program. In fact, I was a resource person in the phase 1 also. So thanks for inviting me once again in this phase 2 training program. My non-technical lecture would be centered on structural break, dummy variable model, and difference in difference model. So this would be a non-technical lecture. And in this particular lecture, difference in difference model is basically the nucleus. And we shall try to digress some of the issues relating to dummy variable and structural break. Okay. Now, before considering difference in difference model, let us now shed some lights on the broad canvas of experimentation. Okay. Now, if you consider the broad canvas on experimentation, then difference in difference model It can be one particular method of quasi-experimental design. So let us now consider experimentation, then experimental design, then different forms of experimentation design, and then we shall consider difference in difference model. But please remember, this would be a non-technical type of lecture. We shall try to consider some of the issues relating to difference in difference model. So this is our basic point of interest. Okay. Now, directly, let us now start with experimentation. Now, experimentation is commonly used to infer causal relations. So it is basically used to draw causal relationship. So, but here you have to remember, by the term causality, it cannot do a different meaning. So whatever ordinary person they are trying to understand by the term causality, it is to some extent different from what a scientist perceives. Okay, so scientific meaning of the term causality is to some extent different from the ordinary meaning of the term causality. Okay, now by if we consider the ordinary meaning of the causality, then we often argue that X is the only cause of Y. This can be one argument that X is the only cause of Y. But if you consider the scientific meaning of the term, okay, so that means the finest way to conceptualize the problem of causality, then X can be one of the number of possible causes. It is not only one cause. So there may be several other causes. So it is one of the number of possible causes of Y. So this is the basic point of difference in between what the common person they are trying to understand by the term causality and what the scientists they are actually interpreting the term causality. Okay. Now it is possible to prove that X is the cause of Y. So ordinary person they have the perception that we can prove that X is the cause of Y. But but if we consider the scientific meaning, then we are not basically trying to prove. Okay, and it is not possible to prove. So if we consider uh, uh, argument given by Lind Bacon, then we can say that while experiments cannot prove causality, experimentation is the best method for making causal inferences. So in order to draw causal inferences, okay, experimentation can be a best method. But by using experimentation, you cannot prove anything. You cannot prove anything. Okay. So it is never possible to prove that X is the cause of Y, but we can infer or we can assume that X may be one of the possible causes of Y. So this is the basic point of difference. Now, if you consider some of our scientific experiments, as Newton's law of gravity, Occam's law, then we can determine the outcome of Y with certainty. Okay, so if we can determine the outcome of Y with certainty, then we can say that X may leads to Y. X may leads to Y. So it can be applicable in case of some universal law. But in general, it is not so. In general, it is not so. X makes the occurrence of Y more probable. More probable. That means probabilistic outcome. Probabilistic outcome. That means here we are considering an elements of probability. An elements of probability. And probability is nothing but a measure of crude measure of uncertainty. Okay, so we can argue that X makes the occurrence of Y more probable, more likely. Okay, so here X is the probable cause of Y. So in general, in our real life situation, we can say that there is all other situations they are probabilistic. Okay, there are some other situations where you can find out some of the universal laws, and thereby using these universal laws, you can determine the outcome with certainty. But here, in case of any scientific experiment, in other scientific experiment, X is only a probabilistic outcome of Y. Okay? So this is the basic point of departure. In this particular term, an ordinary person, what they are understanding, and what the scientists they are trying to interpret it in the term causality. Okay, so this is the basic point of deviation. Now here we are trying to understand experimentation in the backdrop of a research problem. In the backdrop of a research problem. So basically, we are trying to contextualizing the problem. Okay, so understanding one particular methodology in the context of a research problem, these can be the need of the hour. Okay, so if we are trying to understand methodology, okay, without any research problem, okay, then it's very difficult to apply. Very difficult to apply. So try to understand this particular methodology in the context of a research problem. And it is often said that without context there is no text. Okay, so context is very much important here. Now, if we consider the article written by Duflo, one of the Nobel laureate economists, so he has made a policy, and in her experiment, actually, she is trying to evaluate the role of school construction, so infrastructure development in the school. So, what is the impact of the infrastructure development on schooling and labor market participation? So this is basically one experimentation or one impact assessment technique. By using impact assessment technique, in particular difference in difference, actually she tried to evaluate the role of school construction on the behavior of the school and the labor market participation of the household. So this is the basic point of interest. It was published in American Economic Review or leading economic journal. Now we have tried to contribute something in this particular domain. Actually, by with our co-author like Subra Sinha and Nilojyoti Kumar. Actually, I have tried to contribute something in this particular domain, and my article was subsequently published in Studies in Agricultural Economics, one of the Web of Science listed journal. And in this particular paper, we are trying to evaluate the role of food price shocks on the changing pattern of consumption expenditure. Okay, so this is basically our point of interest. What is the impact of food price shocks on consumption pattern in the context of Indian economy? So this is one particular paper, and in another paper, we are trying to find out the role of organic farming, and one other particular form is zero budget natural farming. So, what is the impact of the zero budget natural farming on return, cost, and profitability of the farmer household? Okay, so this is basically one primary survey, and here also we have employed difference in difference technique. So these are some of the contribution we have tried to contribute in this field of research. Now let us stick to our attention on our second article, that means impact of food price shocks on the consumption expenditure. Now, in the context of liberalized trade of agricultural commodity, global food price shocks accelerated at a faster pace since 2007. Since 2007, we have seen that there is an increasing trend in the global food price level. Okay, and the volatility and the price volatility, they have a connection, they have a nexus with the problem of food security. And when we are saying that we are facing food security, then we are conceptualizing the problem in a multidimensional aspect. Okay, now food security can be perceived as a multidimensional construct. Okay. Now, it can be of 4 dimensions: availability, access, utilization, stability. Now, if we consider the dimension, then availability of food may not ensure access to food. Okay. So, availability of food, if the food is available, but you may not have much access to the particular amount of food because you require purchasing power. You require purchasing power to access of food, and it can be measured by monthly per capita consumption expenditure. Okay, so monthly per capita consumption expenditure is one of the approximate measure of your purchasing power, and thereby it can be a measure of access to food. Okay, so this is basically our conceptual framework. We have conceptualized the problem of the linkage between price linkages with food security in this way. And if we are trying to search for the underlying variation, so there is obviously there is a variation in consumption expenditure by the household, but it can be explained by spatial differences. That means there can be differences in rural India and there can be differences in urban India. So spatial differences is also there. So this is one source of variation. Okay, so variation in consumption expenditure can be explained by spatial differences. So this is one form of difference. So in difference, we are considering two such differences. So one form of differences can be due to regional variation, can be due to regional variation, can be due to rural and urban India. Urban India, okay, so consumption expenditure in rural and urban India. These can be one sort of variation. There can be another sort of difference, temporal differences. Okay, so before food price shocks and after food price shocks. So these can be another source of variation, another source of variation. These can be the second differences. So first differences is regional differences, second difference is temporal differences. So basically we are considering differences in differences. Okay, so this is the basic conceptual framework of our research paper, where we have extensively applied this particular technique. Now before going into the directly the technique, let us now try to understand how NSS, National Sample Survey, they are measuring consumption expenditure. So they are reporting consumption expenditure across decile classes. Now what do you mean by the decile classes? Actually, if we consider NSSO definition, NSSO, National Sample Survey, then they are reporting consumption expenditure data across decile classes. And the first decile classes, 10 to 20%, it comprised of the bottom 10% of the population in terms of MPC, marginal per capita consumption expenditure, and top 10%, 90 to 100. Okay, this is the top 10% decile class. It consists of top 10% of the population. And in the segregation, whatever segregation we have, in this particular segregation, the top 10% of the decile class, okay, it is again subdivided into 90 to 95, 5%, and 95 to 100%. So this is the basic structure of initial data. Okay, and we have extensively applied these sort of secondary data sources in order to conceptualize the problem. Okay, so so this is all about decile classes. So we are dividing the behavior of the household, okay, in different classes. So the bottom 10% of the population, then the next 10% of the population, and higher and top 10% of. In this way, we are segregating the consumption expenditure pattern across decile classes of population. And here, please remember, here in order to measure consumption expenditure, there can be different methodologies. Okay, and here we have used uniform reference period, U30 uniform reference period, and mixed reference period. Here M stands for mixed reference. Okay. So in order to represent your consumption expenditure across decile classes, you can have different methodologies of measuring consumption expenditure. One is uniform reference period, another is mixed reference period. So but there can be another one. Modified mixed reference period. This can be another method of measuring consumption expenditure. Now, how these methods are different from each other? Now, in the uniform reference period, as the name suggests, here we are considering expenditure for the last 30 days. Okay. So these are some of the items. Okay, and we are recording their consumption expenditure for the last 30 days. So in the uniform reference period is remains the same. Reference period means your recall period. Please recall that what you have consumed in the last 30 days. Okay, on clothing, bedding, footwear, education, medical. So these are basically recall period of the expenditure, recall period or the reference period. Okay. Now, in case of mixed reference period, it is to some extent mixed. That means for the first item, you are considering the last 360, last 1 year as your reference period. In other two items, you are considering 30 days as your reference. So this is mixed in this sense. Mixed in this sense. Okay. If you consider modified mixed difference, then for the first item it is your last year consumption expenditure. For the second item it is the last 7 days consumption expenditure. For the third item it is your last 30 days consumption expenditure. So in this way there are different methods of measuring consumption expenditure. Okay. Now directly let us now consider experimental design. So this is the backdrop of our analysis. Okay, so this is our research problem. We shall consider methodology in the perspective of our research problem. Okay. Now in experimental design, we are conducting experiment. We are conducting experiment. So actually, in an experiment, we are manipulating one or more independent variable and measures their effect on the dependent variable while controlling for the effect of extraneous variable. So what does it mean? Actually, if you consider our research problem, then our regional variation, rural urban differences, and our temporal variation before crisis, after crisis. So these can be the independent variable. Okay. So in our experiment, we are trying to capture the impact of regional differences. We are trying to capture the impact of the temporal differences on the behavior of consumption pattern. On the behavior of consumption pattern. So monthly per capita consumption expenditure, these can be our dependent variable. So we are trying to identify. We are trying to identify the sources of variation. The sources of variation in consumption expenditure, and we have identified two sources. Okay, one is regional differences. This can be your independent variable. Another one is temporal variances. So these can be your another independent variable. Okay, and we are controlling the effect of extraneous variable. So now here, method of measuring consumption expenditure, this is our extraneous variable. Why? Because you have to control the effect of measuring consumption expenditure. Okay, so in different methods you have different expenditure. Okay, so you have to control the effect of measuring consumption expenditure. So measurement of consumption expenditure by using uniform reference period, by using mixed reference period, these can be your controlling variable. So you have to control their effect.
Arindam Laha sir.
In order to determine the likely impact of the independent variable on the dependent. So
Hello.
this is basically our task. In experiment, we
Hello.
are often manipulating the impact of independent variable on dependent variable. And here we assume that we have controlled the effect of extraneous variable.
Hello, Arindam Laha sir. Hello.
1 minute, please.
Sir, can I ask the question?
Please.
Sir, how we can control the extraneous effect of the extraneous variable?
Okay,
the way there is an impact of the extraneous variable on the consumer. And it is going on the system. So how we can control the impact of the extraneous variable?
Okay, I understand the problem. In fact, now here there is a role of dummy variable. Okay, so in our next presentation, I shall try to shed some lights on the role of dummy variable. So if you use dummy variable, so if you use different measures of consumption expenditure by dummy variable, then you can control their effect. So you have to include in your equation, you have to include the effect of measuring consumption expenditure. Okay, so these can be your another explanatory variable, another independent variable. So if you use measures of consumption expenditure, so either it can be uniform reference period, it can be your modified reference period. If you use a dummy variable here, then if you use the dummy variable and if you use the dummy variable as an explanatory variable, then only you can control the effect of extraneous variable. So please be patient. In our next slide, we shall try to consider that how you can control the effect of extraneous variable. Okay. Now, at the present time being, let us now consider our test unit, now our individual level of consumption expenditure across decile classes, these can be our test unit. So these, so the household level consumption expenditure, they are divided into homogeneous subsamples. That means we have different decile classes. So these can be our homogeneous subsamples. Okay. And our test unit is nothing but our household level consumption expenditure. So this is one set of procedure, one particular unit. Then I have made a discussion on the choice of independent, choice of dependent, and extraneous variable. So these are some of the issues related to experimental design. Now, if you consider the classification of experimental design, then it can be classified into four basic methods. So in pre-experimental design, this is the first method, one of the crude measure of conducting experimental design. Okay, but here, please remember, there is no role of randomization. In the pre-experimental design, there is no role of randomization. We do not control for extraneous variable by randomization. Okay, so there is no such control of extraneous variable. This is just like one shot game. In one shot game, you are trying to evaluate the impact of independent variable on dependent variable, but without any exercise on randomization. So you are not in a position to do randomization. So you are actually applying this particular technique. But if you can randomly assign your test unit, to experimental group, that means here we are considering two particular groups. One is your experimental group, or it can be known as your treatment group, and another one is your control group. And if you randomly assign household into treatment group and experimental group, treatment group and control group, okay, then actually you are applying true experimental design. Okay, this is the finest way to apply experimental design in true sense. That means if you want to apply experimental design in true sense, you have to randomize. You have to randomize your test unit, and you have to consider one particular experimental group or the treatment group, and another one is your comparable group or your control group. So in this way, if you can randomly assign test unit into different groups, then actually you are applying true experimental design. But in practice, we are often familiar with quasi-experimental design. Okay, because here we have a problem. It is very difficult to randomize your whole experiment. Okay, so full experimental control is sometimes lacking. There is a problem in controlling in randomizing the whole exercise. Because here sometimes you have an access to the secondary data source. So I have an access. I have utilized INSS data on consumption expenditure, but the survey procedure is to some extent is beyond my control. It is not our control. So INSS, so they have their own methodologies of conducting survey. Okay, obviously they have used randomization, but it is not our primary survey. Okay, so we are unable to expose test unit to the treatment randomly. Okay, so randomization, a partial sense of randomization is there. So partially, we assume that there is a possibility of randomization, but we are not sure whether they are doing the randomization exercise in proper sense or not. Then instead of considering true experimental design, if you are using your secondary data sources, then it would be better to apply quasi-experimental design. So in practice, in general, we often habituated with quasi-experimental design. When the true experimentation you cannot perform, you have not full control of your data set. You are using your secondary data. Okay, you are not using your primary data. Okay, so you are using your secondary data, and you want to have an outcome in a less expensive way, in a quicker, in a faster way, less expensive way. Okay, then we are often habituated with quasi experimental design. So these are some of the situations where you can apply where you can apply quasi experimental design. And please remember, difference is one of such method. Is one of such method. So it is one method of quasi experimental design. Okay, and there can be another method, statistical design. So randomized controlled trial. Okay, randomized controlled trial, factorial, Latin square design. So these are some of the statistical methods, okay, to control external to to conduct experimental design. Okay, so some of the methods you have in our statistical literature, so you can apply this particular method for the purpose of experimentation. Okay, but my basic point of interest would be on quasi experimental design, and as I have told you earlier, DID, difference in difference, is one such innovative method. Okay, now in this particular method, we are trying to identify two groups, as I have told you earlier. Treatment group, one is your treatment group, that I mean they are affected by the policy changes. Okay, and there can be another group, another control group, they are not affected by the policy changes. So two different groups may be there, and we have to be judicious in selecting our control group. Okay, we must be careful. Okay, while selecting your comparable group, that means control group, uh, so control group selection is very important because it ultimately determines the quality of the evaluation. When we have done our primary survey on organic farmer, then the farmer who are using who are using chemical farming, they are our control group. So treatment group is organic farming, and they have formed an organic cluster. Okay, government intervention is there. They are following Paramparagat Krishi Vikas Yojana. In this particular central scheme, they are forming one particular cluster, and they are practicing they are practicing organic farming. But while selecting your control group, okay, you have to choose some of the comparable farmer, comparable chemical farmers who are residing in the same location, So selection of control group is very much important, and it ultimately determines the quality of your evaluation. Okay? Now there are three ways, different ways to look into the problem. So three very simple ways, very simple measurement technique is there. You can use box, okay. So representation by the table. You can graphically represent the problem, or you can employ regression technique. To conceptualize the methodology. To conceptualize difference methodology, there may be three different ways. Now, let us now start with, before considering the three different ways of presentation. Okay, let us now consider some of the underlying assumptions. Okay. Now, the first assumption is related to additive structure of effect. That means here we are imposing a linear restriction. That means here, if we consider that, we suppose here Y is nothing but your consumption expenditure, household level consumption expenditure across decile groups. Okay, so Y is your monthly per capita consumption expenditure. Now you are considering a treatment group. That means here T can be one dummy variable. So we shall try to we shall consider this particular specification in my discussion. Please wait. But here we are adding the impact of regional variation. We are adding the impact of temporal variation, and we are adding their interaction effect. Okay, so we are adding their effect, regional effect, your temporal effect, and your interaction effect. We are adding. Okay, so this is basically linear model. basically a linear model, and we are adding the impact of several independent variables in our model. Okay, so in a simple sense, we are using our linear model, and we are adding their impact. We are adding their impact. Okay, and we are choosing our treatment group and the control group, and there is no overlap. There is no overlap. Okay, they are basically two sets of that means rural India and urban India. Okay, two different regions are here. Okay, so treatment group, if you consider one treatment group, rural India is considered as a treatment group, then urban India should be considered as a control group. Okay, and there is no scope for considering semi-urban, because semi-urban is basically an overlapping region. So when you are choosing control group and treatment group, you must remember that there should not be any spillover event. Okay, either you receive the treatment, either you are practicing organic farming or you are practicing chemical farming. In some season you are practicing organic farming, in some other season you are practicing chemical farming. Okay, so this is not your ultimate testing unit. You should not consider this type of household, because it's very difficult. You have to either switch off to the organic farming, or whatever you are doing, you must be satisfied with your chemical farming. Okay, so so here overlapping group is not there. So this is our assumption. So when you are selecting control group, you must be judicious. You must be judicious in selecting control group. Ultimately, your evaluation is dependent on the selection of the control group. That means who are actually receiving the treatment, they are your treatment group, and who not receives your treatment, they are on the control group, and there is no overlap, there is no spillover. Okay, this is your second assumption. In a third assumption, you assume that difference between treatment and control group would have remained constant in the absence of treatment. Okay, very important, very important. Let me here, if you consider the diagram, now here, suppose you have enrolled in a particular program. In fact, you are now participating in our short-term training program on econometrics. So you have enrolled. Okay, so this is your productivity. Okay, and those who have not enrolled, okay, they may be your friend. They have not enrolled. They have not enrolled in this program. So these can be their productivity. You have enrolled. These can be your productivity. Okay. Now, if there is no intervention, what does it mean? Let me here. You are actually participating in this particular training program. This is known as the intervention, policy intervention, PICTC. Actually, they have sponsored this particular program. Why? Because in order to enhance your understanding on some of the issues related to econometrics. Okay, so this is your intervention. So intervention actually, so at the time t is equal to 0, intervention takes place. Actually, this is the time period where you are intervening. Okay. So now, this is now the time period. Here we are intervening. Intervention takes place. Okay. Now we want to evaluate. We want to evaluate the role of intervention at the time period t is equal to 1. At the time period t is equal to 1. Okay. So here, so in the meantime, there may be change in productivity. Now, if you follow my last assumption, that means if there is no such intervention, your productivity and those who are not yet enrolled, their productivity, the gap in productivity remains the same. So here, dotted line. So if you consider the dotted line, movement of the dotted lines, then here the behavior remains the same. So the gap, whatever gap you have before intervention, the same gap will remain. It will remain. Okay, if there is no intervention. Okay, but here you can find out if there is intervention. If you are participating in the training program, then this can be the trend of your productivity. These can be the trend of your productivity. So your productivity in fact increases. If there is no intervention, your productivity can be represented by the dotted line, and it follows the similar pattern as that of your control group who have not enrolled in the program. Okay, so the gap would remain the same in the absence of intervention. But as we have a training program, okay, and if your productivity increases, then from there you can estimate the impact of intervention. Okay, so if there is a change in productivity, okay, if there was no intervention, then these can be your productivity at the time period 1, t is equal to 1. But as a result of the training program, your productivity increases to this much here. Your productivity increases here. Okay, so the gap is actually reflecting your average treatment effect, AT average treatment. So what is the effect of the treatment? Okay, so we have done an experiment. Then what is the effect? Basically, it is known as the impact assessment. Okay, you are assessing the impact of the training program. Okay, so this is the basic conceptualization of the problem in terms of graphical presentation. Okay, now there can be another ways to represent the problem. So here we have some numerical facts and figures. Okay, by using this numerical facts and figures, we are trying to conceptualize the problem in a graphical way. Okay, now suppose this is the productivity trend of the control group. Those who have not participated in this trend. Okay? One minute. Please. Any problem? I cannot hear you. 1 minute.
Participant, do you have any query? Alka ma'am?
Oh, 1 minute, please. I cannot hear it. There will be sound system.
Alka ma'am, do you have any query? Laha sir, I don't think so. Anyone have a query? You can carry on your PPT.
Problem. Microphone had a problem. Then 1 minute. Hello.
Yes, sir.
Hello.
Yes, Arindam sir, we can hear you.
Pallavi.
Yes, Arindam sir, we can hear you.
I can also hear you, but the sound, there is a problem with the sound.
No problem, sir.
One.
No problem, sir. You can manage your problem. No problem. Take your time.
কি করবো? Pallavi.
Yes, sir. Yes, yes, Arindam sir. You can ask. I'm Sunita.
So one.
Ma'am.
Ma'am,
Yes, let me give you the permission of co-host and other. So please wait. Let me give you the permission. Yes, sir. Arindam sir, I have given you the permission of co-host. Now you can start your session, and I hope now you are not facing any problem.
connected.
Okay, okay.
Hello.
Yes, sir. Yes, sir. Arindam sir, please open your video.
Sorry. No. Suja.
Done, sir. You can start. Arindam sir,
Please.
voice is clear from my side.
No, voice is there is a problem in the voice. I can hear you, but the sound is very low. I cannot hear you properly. So this is the problem I'm facing in my microphone.
Okay, but your but voice from your side is absolutely clear.
Oh, from my side, it is actually clear.
Yeah, so it's my request. You can take your session. It's my request. You can take your session. And if participants are, they want to ask any question, so they can write in a chat box.
Okay.
Okay?
So please try to write your questions in our chat box.
Definitely, sir. Definitely, sir. If participants are like if they want to ask or they have any doubt in any topic or anywhere, I request to all participants, please write your question and doubt in the chat box. In the behalf of you, I'll ask to sir or I'll inform them meanwhile. And Laha sir, your voice is absolutely clear to all participants. You can take your session. You can start your session again.
Okay. Thank you, ma'am.
Thank you.
Uh, so actually, so this can be another way to visualize the problem. Uh, now here, this is the trend of productivity. This is the trend of productivity for the control group, okay, and this is the trend of productivity for the treatment group, okay. And in the absence of any experiment, in the absence of any intervention, these can be the trend of productivity for the treatment. Okay, so the gap is expected to remain the same. If you follow our third assumption, that the gap is expected to remain the same. But as there is an intervention, this is the actual trend of productivity. This is the actual trend of productivity. Okay. Now here, if you consider the difference in productivity, now here 80 is one particular measure of productivity for the treatment group, okay, and 30 is your control group. So if you subtract 30 from 80, then 50. These can be the impact of intervention. So if you assume that 80 minus 30, 80 minus 30, okay, from the end point, if you are making a difference, then it is exactly 50. But 50 may not represent the true problem. It may not represent the true problem because initially these two groups, they are not on the same wavelength. They are not on the same wavelength. There can be difference in productivity. So initially, for the control group, it is 20. For the treatment group, it is 40. So initially, there may be 20% gap in productivity. So you have to consider 20% gap in productivity in considering the ultimate impact of intervention on productivity. Okay, so actually what you are doing, you are subtracting 20 from 50. Then ultimately 30 is your measures of productivity. Okay, so after treatment, what is the gap? 80 minus 30. Before treatment, what is the gap? 40 minus 20. Okay, so you have to subtract 20 from 50. Okay, and ultimately you could have 30. So these can be the ultimate impact of productivity. This is one such measure. Okay, there can be another similar kind of measure. Now for the treatment group, what is the gap? After treatment 80, before treatment 40, before treatment 40. Okay, so here 80 minus 40, 80 minus 40. So here treatment group, and for the control group, here it is your 30 minus 20. 30 minus 20. So for the treatment group 80 minus 40, for the control group 30 minus 20, ultimately you can have 30. These can be the another way of measuring. So in mathematical terms, these can be the expression. So for the treatment group, what is the difference before and after? Okay, and for the control group, what is the difference before and after? Okay, by considering two such differences, we are actually estimating difference in difference estimate. So this is one such measure, difference estimator. We want to measure difference estimation estimated by using this particular formula. Okay, this is one particular formula. Okay, so now the same problem can be represented by using the box, by using a particular bimetrics table. So in this table, after the program start, so after and before, after the program start, these can be your measure of productivity. Okay, who have received the treatment? Who have received the treatment? Okay, so this is the common those who have received the treatment, and what is their productivity after the program, after completion of the program. Okay, so this is the measure of productivity. Similarly, what is the now for the control group? What is their productivity here? Now, before the start, what were the productivity for the treatment and the control? So these are some of the figures relating to productivity for the before the training program. Okay. Now if you consider the treatment group, then from there you can have one form of difference. Okay. So after minus before here. Similarly, for comparison group or the control group, you can have also one form of difference after and before. One form of difference. Okay, and in difference estimator, you are considering both the differences. Okay, this is one difference, this is another differences, and you are considering difference in differences. So you are subtracting second difference from the first one. Okay, so ultimately you are trying to measure different estimated. Okay, so this is the same problem, whatever the problem you have in your graphical presentation, the same problem is also represented by using box. Now, in the context of our research problem, so here pre 2008, pre-crisis and post-crisis, and you have another source of variation, and urban, and these are basically measures of consumption. Okay, measures of consumption. So mean consumption. So in the rural area, mean consumption for rural India in post-crisis situation. Okay. Similarly, mean consumption for rural India in pre-crisis situation, and you are considering the difference in the consumption level in pre and post situation. Similarly, you are considering difference in consumption level in the pre and post situation. And here you are considering difference in differences. Okay, so this can be the representation in the context of our research. And what we have trying to establish. Actually, what we have found is that there is a spatial difference. I mean, rural consumption expenditure, they will decline. I mean, consumption expenditure in fact declines. Now here, this is the table relating to rural consumption expenditure, and here we have chosen median class as the control group. We are choosing median class as the control group. Okay, median. So just these are basically decile classes of population, and from the decile classes of population, you are choosing middlemost value. Okay, you are choosing middlemost value. So these are the median class of population. So for the median class of population, these can be the change. These can be the change before crisis, after crisis. These can be the change. Okay, and there is a slight change, 1.18. These are measured in terms of rupees. Okay, so 1.18. This is the only change in case of median classes of population. But if you consider the bottom 10% of the population, then there is 25 rupees change in the consumption expenditure. 25 rupees change in the consumption expenditure. So what is the net change? What is the relative change? It is nothing but 24. So in comparison to median classes of population, okay, what is the decline in the consumption expenditure for the bottom 10% of the population? So what is the net impact? Net impact can be 24% decline in the consumption expenditure. So this is nothing but difference in differences. Okay, this is nothing but difference in differences. We are considering two such differences. So 25 is the 25 decline is the differences for the lower 10% level of population. Okay, 1.18 rupee decline is the is the decline for the median level of consumption, and here 24 rupee decline is the decline in lower level of lower 10% class of consumption with reference to the median class of consumption. Okay, and for the treatment group here, now before situation, this is the decline. After situation, this can be the decline. So after situation, there is a decline is to some extent higher. Okay, so what is the ultimate impact? Ultimate impact is there. So these are the red mark figure. They are basically your relative change. They are basically relative change, or in other words, this can be your difference in difference estimated. You are actually basic point of interest is that you are actually trying to estimate difference in difference estimate. So decline in consumption in the rural India is visible. Similarly, for the urban India, decline in consumption is also visible. But what is the but how can you compare? How can you compare? So if you compare the difference in difference figures, so difference in difference figure, then the who are the worst affected? So lower population group, lower decile class of population, okay, they are the worst affected. Here 20 rupee decline here, and those who are on the top, that means those who are at a higher decile class from 80 to 100, there is also decline in consumption. So these two groups, those who are on the lower end and those who are on the higher end, both they have experienced a decline in consumption. Okay, so in median people, there is no such significant change. Changes are there, but it is not so much statistically notable as that of these two sections of the people. And urban India, the impact in urban India is to some extent higher. Relative loss in urban India is to some extent higher than the rural India. So this is and this can be also established by considering urban India. If you consider urban India as your control group, rural India as your treatment, then what is the difference? What is the difference? And here, in most of the situation, difference in different estimator, with the figure which are represented by the red color, they are positive. That means here, urban India, decline in urban consumption. Decline in urban consumption in post 2008 is distinctly notable in comparison to rural India. So decline in consumption in urban India is to some extent higher than decline in consumption in rural. So this is my basic point of observation in my opinion. Now, one of your participants, they have raised a question that how can you trying to control the variable, extraneous variable. So now, in order to understand the problem, let us now digress some of the let us now digress our discussion on dummy variable. Okay. Now, there's some of the basic concept. You may be familiar with this sort of concept. Okay, it is basically trying to capture qualitative information. You have a classified data. And you have different categories, and the categories, they are mutually exclusive. That means here they are mutually exclusive. That means here there can be no overlap. Either there can be male or female, rural or urban. Post 2008, pre 2008, measure of consumption expenditure. Either you are dependent on URP or MRP. Dependent on URP or MRP. Okay. So these can be some form of classification, and there is no overlapping. That means here mutually all such groups. Okay, we have classified the groups, and there is no such and they are mutually exclusive. One happens, and the other do not happen. Okay, and here Now, we have an misconception. We may have some misconception that that mean here that means we are dealing only with you are dealing only with your that means regression framework can be applied only in case of metric data. Okay, there may be misconception that regression framework can be applied only in metric data. It is not. Okay. Now ratio data. If you consider interval data and
हेलो अरिंदम सर,
scale,
हेलो
so measure.
सर, आपका स्क्रीन शेयर नहीं हो रहा है सर,
Ratio
स्क्रीन शेयर नहीं हो रहा है सर.
screen share नहीं हो रहा.
यस सर, प्लीज स्क्रीन शेयर कर दीजिए सर.
Sorry.
यस सर, अब स्क्रीन शेयर हो रहा है. यस सर, विजिबल विजिबल.
Thank you very much. Thank you for your feedback. Now, if you have ratio data or interval data, then there is no problem in regression. Okay, but there is also no problem in regression if you are using nominal data or ordinal data. This is the new idea. Okay, so regression framework is not applicable only in case of your metric data. So metric data, by the term metric, we are actually trying to understand ratio data and interval data. And by the non-metric data, we are trying to consider your ordinal data, nominal data. Okay, but so regression framework is also applicable in case of nominal data or in case of ordinal data. Now, so here, dummy variables, they are also known as indicator variable, categorical variable, qualitative information, and it can be measured in nominal scale. It can be measured in nominal scale. Now we have a separate discussion on dummy dependent variable. Logic, probably you are already familiar with this sort of regression framework. Okay. And it is my last class. So, dummy independent variable, ANOVA and COVA, you may not be familiar with these sort of regression techniques. Okay. Now, in this particular technique, dummy independent variable, this is my point of discussion, because dummy dependent variable, it can be a matter of discussion for another session. And already you have an idea on the dummy dependent variable. But if you are using dummy variable as an independent variable, then you are allowing differences in intercept, differences in slopes. Okay. So and cross equation. So one equation you can set for urban India, another equation you can set for rural India. So cross equation restriction you can impose, or you can test whether there is any stability in the model. So whether your regression is actually giving you an average kind of relationship. So whether the average relationship persists over the long period of time or not. Okay, so these can be your testing for stability of regression coefficient. Okay, so if you use dummy variable as an expected variable, then actually you are doing this sort of analysis. And in the ANOVA model, actually you are considering regression variable, and they are exclusively dummy variable. Exclusively dummy. That means regressions, they are exclusively based on dummy variable. That means here we have a region dummy variable. Region 1 for rural India, 0 for urban India. So this is one dummy variable, and it is only there as your independent variable. Okay, there is no other independent variable. Okay, so these can be your ANOVA model. But if you relax this assumption, and if you allow other quantitative variable as your independent variable, okay, like your income is another quantitative variable which can have a notable impact on consumption expectation, and you are allowing your income variable, okay, with regional variable. So regional variable is already there. So it is basically a mixture of quantitative and qualitative variable. So if there is a mixture of quantitative and qualitative variable, and it is just an extension of the ANOVA model. So ANCOVA model is just an extension of the ANOVA model. Okay, so you are actually, so here this can be, income can be your control variable. Okay, extraneous influence of extraneous variable. Okay, income, because this is also covariates with consumption expenditure. It is also covariates with consumption expenditure, and you are including income as an independent variable. So these can have an extraneous implication on consumption expenditure. So these can be the empirical specification of the ANCOVA model. Now let us now consider some application. Now here we have shown you how to apply ANOVA and ANCOVA model by using STATA. And you are familiar with STATA. Perhaps you are familiar with STATA, but you have to remember this is a general purpose proprietary statistical software. Proprietary software you have to purchase, or you have to collect by some other means. You have to collect, because it must be backed by some proprietary licensing rules and regulations. And this software was created in 1985 by Statakovs. And the name STATA is actually a syllabic abbreviation of the word statistics and data. So statistics and data, or STATA. Okay, so this is the basic abbreviation. Now I have given you a data set. Perhaps I have already mailed an attachment. My study material. I have prepared a study material. So obviously these are some original source of references. And here also I have provided you the sort of presentation, application of outcome of the software. I have already given to you, and in the attachment I have also given to you a Excel sheet. Okay, data set. Basically, it is one part for some form of data set. Now, in the data set, by using data set here, you can input the data. Now, at first, you have to import the data. If you have the data set, please open the data set. Please open the data set, the ANOVA 1. Okay, so please open the Excel data set. The first name of the set, first worksheet. The first worksheet is renamed as ANOVA 1. And in this particular data set, okay, if you consider this particular data set, then we have a dependent variable. This is our consumption expenditure across decile classes of population. Consumption expenditure, just consider is your monthly per capita consumption expenditure. And we have a dummy variable. This is very simple. We have a dummy variable. One stands for rural India, and 0 stands for urban India. And it is basically a dummy variable. This is basically a dummy variable. Okay, binary kind of nature, 1 and 0. And there is no consideration of semi-rural, semi-urban. This is not our consideration, because in dummy variable we are actually considering the presence or absence of an attribute. And there is no mutually exclusive category. And obviously there will be mutually exclusive category. One happen, either another may not happen. One happen, another should not happen. Okay. Now in the STATA, at first you have to import. There may be several other techniques to import the data, but here we are trying to. So here, if you consider, okay, please wait.
Addendum, sir. Yes, sir. Yes, sir. It's visible
Can you see
now.
my status screen? So
Yes,
here,
sir.
basically data edited. Okay. So very simple way to input the data, because we do not want to save the data. One sort of application is there. Very simple way. Okay, so variable name. That means the first row is variable or not. Okay, it is variable. Okay. So in the data editor, we have this data set. We have copied from Excel file and paste over here. And then in the command, we are typing regression. In short, you should write regress y and then I. Y is your monthly consumption expenditure, and I is nothing but your dummy variable, regional dummy variable. One stands for rural India, and 0 stands for urban India. Okay, so in rural India, your consumption expenditure is lower, obviously lower. Rural consumption expenditure is lower. Urban India, it is higher. Okay, so this is the basic outcome of this particular model. But here, basically here, 1 minute. Now here, if you consider 17 Indian states, okay, if you have a data set on monthly per capita consumption expenditure for 17 Indian states for the year 2006-7, okay, so to some extent old data set. So if you consider our next tab, next worksheet, ANOVA 2. So in your Excel file, perhaps you have the Excel file. So please open ANOVA 2 worksheet. ANOVA 2 worksheet. Okay. There you can have an MPC data for 17 major states or major Indian states. Okay. So in the data file, so this is my, once again, this is my data worksheet, data editor, variable name. Sorry, because already it is there. Okay. Now this is my new data set. So let us consider a new data set. We have monthly per capita consumption expenditure. This is for 17 Indian states. Okay, and we have two dummy variable. Okay. Now here in this data set, we have considered 3 geographical regions. 6 states, they are from eastern region. 7 states, they are from northwest central region, and 4 states, they are from southern region. Okay, altogether we have 17 Indian states, and this is based on their geographical position. We have this sort of classification. Okay. Now, in order to capture regional impact on consumption expenditure, we have 2 dummy variables. Okay. So we have 3 regions, so we are using 2 dummy variables. Okay. If you have m regions, then you have to use n-1 dummy variable. Otherwise, there is a problem. We shall come to the point in our next discussion, that what is meant by dummy variable trap. dummy variable trap. Okay, otherwise there can be a problem of dummy variable trap. Okay, so the general practice is that the number of dummy variable should be less than one, and the number of categories. Now here we have Eastern region, Northwest Central region, and Southern region, three different regions. And for this purpose, we are using two dummy variables. So please consider that D21 is your dummy variable. It stands D21 is equal to 1 if the state is in Eastern region. Okay, or in some other situation it is equals to 0. Okay, in other situation it is equals to 0. So only in the Eastern region, if those states they belongs to the Eastern region, okay, Assam, Bihar, Chhattisgarh, we have only 1. Okay, in other situation we have 0. Similarly, D3 the dummy variable 3, it also it represents a particular region, Northwest Central region. Okay, for the Northwest Central region, it takes value 1. In other situation, in other regions, it takes value 0. Okay, so this can be another dummy variable D3. Okay, and here now, if you consider the average level of consumption, then in Eastern region, the consumption level, you can estimate the consumption level in the Eastern region, Northeastern region, and Southern region. There can be some numerical figure. But whether they are statistically different. So this is our basic point of interest. So even though numerical figure actually exhibiting some sort of differences, okay, so there is a difference in the numerical figure. Eastern consumption is to some extent different, but whether there is a statistical difference. So in order to examine whether there is a statistical difference or not, we have to employ statistical technique, and ANOVA is one such technique. By using ANOVA, you can understand whether there is any statistical difference or not. Okay, now what you could find out. Now here in this particular regression, so please try to do the regression. So for this purpose, you have to type the format regress here y variable MPC. Here I have written MPC and D2 D3. Okay, HA stands for household size. So forget about household size. Let us now consider only dummy variable. Let us now consider only ANOVA model where you have only dummy variables on the right hand side. So D2 and D3. Okay. Oh, sorry, I have written Y. So instead of Y, here you have to write MPC because in the heading it is there MPC, then D2, then D3. Okay. So here. So this is the final output. Now from this final output, what is the basic conclusion? So basically here, if you consider Southern India is considered as a benchmark category. So it is your control group. Benchmark category. So we have two dummy variables. One dummy variable for Eastern region, another dummy variable for Northwest Central region. Okay. So obviously, Southern region is considered as a benchmark category. Okay. Now, if D2 is equal to 0, D3 is equal to 0 in this equation, then ultimately what is your mean consumption expenditure? 1097. So 1097 is basically the mean consumption expenditure of the Southern region. Understand? So this is basically the mean consumption expenditure of the Southern region. Why? Because it is your reference group, your control group. Okay. Here D2 is equal to 0, D3 is equal to 0. So ultimately it stands for 1097 is nothing but the mean consumption expenditure of the Southern region. Now D2 stands for a dummy variable. It actually represents Eastern region. So and here and here it is minus 241. So what does it mean? That means here that means in eastern region, mean consumption expenditure is lower by 241 rupee, by 241 rupee. So if 1097 is your mean consumption expenditure for the southern region, then for the eastern region, okay, if we subtract 241 from 1097, then it is ultimately 856. So 856 is your mean consumption expenditure. Mean consumption expenditure for eastern region. Okay. Similarly, if you want to consider what is the mean consumption expenditure for the northwest central region, then you have to subtract 30 rupees from 1097. Ultimately, you can have 1067. So 1067 can be the mean consumption expenditure for northwest central region. Okay. So in this way, you can calculate the mean consumption expenditure for 3 different regions. Okay, there is no problem. But here, whether the difference is statistically notable, whether the differences are statistically significant, no, it is not so. Why? Because here, if you consider the p-value, okay, then except constant, here D2 is significant only at 9%, 0.092. So this is the p-value, probability value. Okay, it is nothing but your level of significance, actual level of significance. Okay, but in general, we are considering 1% and 5% level of significance. So this much of error we can allow. 1% error we can allow. We can allow 5% error. But 10% error, this is the maximum error you can allow. Okay, so if you allow 10% error, then it is significant. So significant at 10% level. But it is not significant at 1% or 5% level. So at 1% or 5% level, D2 and D3, they are insignificant. D3 is highly insignificant. Why? Because it is significant at 80%. Out of 100 cases, you are committing 80% error. This is the level of significance. Okay, so here this is highly insignificant. But here in case of D2, it is insignificant at 1%, 5% level. But if you consider 10% level, maximum you can allow 10%. Okay, in general, you are considering 1%, 5% level. So in general, at the 1%, 5% level, two such dummy variables, they are found statistically insignificant. So there is no regional variation. So even though numerically there is some variation, but statistically the variation is not established. So okay, it is not statistically established. So the consumption expenditure pattern, they are remaining the same across 3 different regions. So these can be your overall conclusion. Okay, let us now ANCOVA model, and for this purpose you have to consider.
Sir, sorry, sir. Can you hear me, sir? Sir, I have one question.
Please.
Can you hear me?
Please.
Sir, can you hear me? I have a question, sir.
Okay, please.
Sir, can I suppose let's assume both the dummies are significant. Let us assume both the dummies are significant. Can I say that my eastern region consumption is less negative in compared to northern region consumption? Can I say that?
Now, please repeat. If your coefficient of the dummy variable,
both significant. Let's assume.
If they are significant, okay. If they are significant, then what can be your overall conclusion? That means that there is a variation in the consumption expenditure. So consumption expenditure varies across regional in different regions, and already you have estimated average level of consumption. So these average level of consumption, there is a notable variation, and if it is minus, minus. So if you consider the constant term, then 1097. Please, one second. Please consider the value 1097. So 1097 can be the mean consumption expenditure. Can be the mean consumption expenditure for the southern region. Okay, and here D2 stands for eastern region. It is minus. That means in comparison to other regions, your eastern region consumption in the eastern region is lower. And if it is statistically significant, if you allow 10% error, it is already statistically significant. So you can argue that with reference to the benchmark, that means the eastern region consumption expenditure in the eastern region is lower than the other parts of India. The other parts, what does it mean? That means here D2 stands for southern region and northwest central region. That means in comparison to the other parts of region, your eastern region exhibiting a lower level of consumption, if it is found significant. Okay, and here also 30. So 30, if it is significant, if it was significant, okay, then what may be your conclusion? There will be northwest central region, mean consumption expenditure in northwest central region is lower in comparison to the other region. And here by the term other region, it includes your southern region and it also includes your eastern region, because here you have specified dummy variable in this way.
Yes.
Dummy variable in this way. For the other region, you have given 0. Okay.
Yes,
so in
sir,
this
clear.
way.
Yes, sir. Clear, sir. Clear.
Okay. Thank you. Next, let us now consider ANCOVA model. Now let us now consider ANCOVA model. Now here in this particular model, we are considering household size. Why? Because here household size represents your quantitative information. Okay, so in addition to these two dummy variable, you are considering household size. Okay. Now, so the same regression. I mean, you are doing the same exercise. Regress MPC D2, D3, and then household size HS. Okay. Then there is one additional variable. Okay, so if household size increases, then monthly per capita consumption expenditure reduces by 334 rupee. So this can be the conclusion, and it is found statistically significant, highly significant, 1% level or 2% level. It is significant. Okay, so it is significant, highly significant. Okay. And household, if there is an increase in the household size, then consumption expenditure declines. So these can be the conclusion. And here, and if you control household size, okay, if you control, this can be your control variable. If you control the household size, then differential coefficient, they are not significant. That means if you consider other dummy variable D2, D3, okay, so D3 is significant at 8% level. Okay, but you are allowing, suppose you are allowing 1% or 5% level. So D2, D3, they are not significant. Okay, so all other differential coefficients, they are not found to be statistically different. They are not found to be statistically significant. Okay. Now let us consider another problem. Now for this purpose, perhaps my PPT is now visible.
Yes, yes, sir, it's visible.
PPT is now visible. Okay. So let us now consider another problem. Now, as I have told you earlier, that now there may be some point of concern. That means there is a possibility. There is a possibility that we may encounter a problem of dummy variable trap. So if we misspecify our regression model, so here suppose in our regression, we have written 3 dummy variables, D1, D2, D3. Okay, we have written 3 dummy D1, D2, D3. So 3 regions and 3 dummy variables. So this is basically is misspecification in our empirical specification. So in our empirical specification, we have done something wrong. Okay, why? Because here there is obviously there is a possibility that your dummy variables, they are multicollinear. They are that means there is a problem, multicollinearity problem. That means if you consider here, if you consider income and consumption, suppose Y stands for your consumption expenditure, and you are considering income as an independent variable, and also you are considering your wealth, as your explanatory variable, income and wealth as your explanatory variable, and your monthly per capita consumption expenditure as your dependent variable. Okay. Now there may be overlap. You cannot disentangle, or you cannot separate out the influence of income and wealth. Okay. So you cannot. It is not possible to separate out the influence, because in the conceptualization of the particular variable wealth, income is there. So income can be one particular component of wealth. It can be of several other components, but income can significant influence on wealth. Okay, but if you choose income and wealth in the same regression framework, then how can you separate out the influence of income and wealth? It is not possible. There can be a common area. This is the common area. What does it mean? Then the variation of income jointly explained by variation of consumption jointly explained by your income and wealth. This can be your common point. Okay. So this is an overlap area. Okay. And here in this particular case, there is a problem is to some extent magnitude of the problem to some extent higher. Why? Because the influence of x1 and x2, these 2 variables, there is completely overlap. Okay, completely overlap. That means in no way you can separate out the influence of these 2 variables. So there is a problem of multicollinearity. Okay, so if you
sorry to interrupt you. Actually, I wanted your recommendation on something. We actually have a break of 20 minutes to 30 minutes in between. But if you don't want to give a break and you want to continue with the second session, then we can do that also. What do you say?
Madam, let us now continue.
Yes, okay, fine.
So if there is no problem from the participants,
yes,
if they have patient, I have no problem.
Okay.
If they demand for a break for 15 minutes or 20 minutes, then I have no problem. So let us now ask my participants.
Participants, you can also write us in chat that whether you want the session to continue or whether you need a 15 minutes break so that we could come back after 12, or can we continue? If we can continue, then please say yes in the chat. Yes, I think Arindamda, we can continue.
Continue?
Yes. Okay, everybody is saying to continue. So please continue. And this is the part of the second session just begun. So please continue with the second session.
Okay.
Ananda, your video has mistakenly switched off. Can you hear me?
Okay, 1 minute.
Your video has mistakenly got switched off.
Okay.
Please go ahead. Continue.
Please. Okay. Now, so here in our real life situation, what we have said if you are using monthly data, then you are using 11 dummies, one less. If you are using quarterly data, you are using 3 dummies, one less. Okay. If you have 2 categories, if you have 2 categories, only binary choice is there, then you are using 1 dummy. Okay, why? Because you are trying to avoid dummy variable trap. Okay, so if general practice is that if you have m category, then it has only you have to use only m-1 dummy variable. Otherwise, there is a problem of dummy variable trap. Okay, so how to now what is the problem? Actually, the problem is a multiple data. Now, if you consider the problem, extent of the magnitude of the problem, then suppose now suppose in the same data set we are using the same data set just like our ANCOVA model we have our D2 and D3 dummy variable and we have household size. Now in addition we are using another dummy variable D1 stands for that means if it stands for Eastern region. So if the states belongs to Eastern region, you are giving 1. So so here sorry, very sorry. So for Eastern region already you have D2. For Northwest Central region you have already D3. So for D1, suppose now you have for D1. So D1 stands for Southern region. Okay, so Southern region is the benchmark category in case of D2 and D3. So D1 for D1, okay, so let us now 1 stands for Southern region. Okay, so 1 stands for Southern region. So here D1. So Andhra Pradesh, for Andhra Pradesh you have 1. Similarly, so here there is a problem in the visibility. But here, suppose here we have given 1 for Southern region and 0 for some other region. So if it is Eastern or the Northwest Central region, okay, it is 0 and 1 for only Southern region. Okay. Now, so here in this specification, it is basically a misspecification. Why misspecification? Because here you have considered 3 dummy variables. So 3 regions are there. You are considering 3 dummy variables. Okay, and you are trying to estimate the impact of regional impact on monthly per capita consumption expenditure. Okay, but the software they will refuse. They will straight away they will refuse to do so. Okay, so if you run the same regression. So so I have the data set already. I have given you the data set. Try to run the same regression in the strata. So replace NPC D1, D2, D3. Then they obviously they will try to omit variable D1. So new variable they will try to omit because they obviously there will be a note of caution that D1 is omitted because of multicolority. So there is a problem of multicollinearity. It is giving you an alert that there is a problem of multicollinearity. You are using three regional variables. You are using three regional variables at the same time. Okay, so you are going to face a problem of multicollinearity. So they are giving you a caution, and in the regression output D1, it will not be there. No estimation will be there in case of D1. Okay. Now suppose in our department, one of my students, suppose they he is facing a problem. There will be number of observations, suppose 10, number of observations 10. Okay, so company wise data, number of observations 10, and number of independent variable is also 10. That means and number of observations 10 and number of independent variable. That means number of observation n and number of independent variable k also 10. Then they will obviously drop one variable, because in general in our Weyler's model, what is our assumption? That n number of observations should be greater than number of explanatory variable. Number of observations should be greater than number of explanatory variable. Okay, so similarly here also they will obviously omit one variable, drop one variable. Okay, they will drop one variable and they will giving you the same regression once again by considering D2, D3. Okay, so they will consider only D2 and D3. Okay, so there is a problem of dummy variable, because if you add D1, D2, D3, all are equals to 1. All are equals to 1. So if all are equals to 1, then D1 is equal to 1 minus D2 plus D3. D2 is equal to 1 minus D1 plus D3. So there is a direct relationship in between D1, D2 and D3. Okay, so this is the problem of multi-collinearity. Okay, and the software, they will refuse to run your regression if you have misspecified your model. If you have misspecified your model, obviously they will try to refuse to run the regression. Now what is the way out? Now way out is to there are two different way outs. One is to consider m minus 1 dummy variable. If you have m category, one less. Okay, and the second way out is to drop the intercept term. This can be the second way out. So if we write our empirical specification in this way, so we are here in this specification, we have not considered any constant term. Okay, we have not considered any constant term. Okay, so why? Because if you do not consider any constant term, okay, then there may not be any problem of multicollinearity. Okay, so the problem then you can avoid the problem of dummy variable trap. Okay, now why? Because if you add D1, D2, D3, then sum equals to 1. So 1 is perceived as your constant. Okay, and if you want to calculate D1, then you are subtracting D2 and D3 from 1. So 1 minus D2 minus D3. Okay, so if 1 is treated as the constant, so deviation from your constant. Okay, when you want to calculate D1, D2, D3, you are deviating from your constant term. But if there is no constant term at all, then there may not be any problem of dummy variable trap. Okay, this is the basic logic. One is considered as a constant. So if constant is not there, then there may not be any problem of dummy variable trap. Now you must be cautious. You must be cautious in typing the comment. So regression REG, and then MPC D1, D2, D3, then comma no constant without any space. You have to type no constant. Okay, you have to type no constant. Okay, data is already with you, so please do your own exercise. So please type regression IG, MPC, D1, D2, D3, comma no constant, but there is no constant. Okay, so here, if there is no constant, then the software in the software you can have this sort of output. So this is the output. Okay, and you can directly estimate the mean. You can directly estimate the mean. Please remember what I have said. So already you have this sort of regression. So here constant is there, D2 and D3 is there. There is no D1. Okay, only D2 and D3. Please remember my earlier result. Only D2 and D3 is there, constant is there. Now you have calculated the mean consumption expenditure in 3 different regions: eastern region, southern region, northwest central region. Okay, how you have calculated? Because 1097 stands for southern region, because here D2 is equal to 0, D3 is equal to 0. This is the common. This is southern region is a common difference group. Okay, so here D2 is equal to 0, D3 is equal to 0. So 1097 is nothing but your southern region. So this is the level of mean consumption expenditure. Now in case of northwest central region, it is D3. So 30 rupees less. 30 rupees less. So 1067 is the mean consumption expenditure in the northwest central region. Okay. In case of eastern region, it is 241 rupees less. So 1097 minus 247 is equal to 856 is your mean consumption expenditure in the eastern region. So in this way, you are actually plotting your variation, regional variation, but it is not statistically significant. As I have told you earlier, it was not statistically significant. The same coefficient is also here. Please find out the same coefficient. 1097. Now 1097 is the southern region. Okay. Then 856. This can be your eastern region, and D3 northwest central region. It is nothing but 1067. So directly you can estimate your coefficient here. Okay. So directly the mean values of consumption in different category here in different region, you can directly estimate. The mean level of average consumption expenditure. But you have to remember that you should not use any constant term. Okay. So you are using constant term as well as you are using D1, D2, D3. Obviously, you are in a trap. You are in a time variable trap. So please remember this sort of problem. Now here, let us now want to introduce one another package. You may not be familiar with Gretel, but it is very user-friendly package. Okay, and here the novelty is that it is a free open source software. You can have this software. Okay, so if you can download this particular software directly, and there is no such payment. It is not proprietary software. It is a free open source software. Anyone can directly download the software from the specified URL. I have specified the URL. You can download this software. You can done the same exercise. So Stata is a proprietary software, as I have told you earlier. There is a restriction. You may not have an access to Stata. Okay, but if you want to employ this sort of analysis, whatever analysis I have done, you can do the similar kind of exercise by using Gretel. And it was developed by Ramu Ramanathan, one of the noted econometrician. Okay, so we have a book on econometrics written by Ramu Ramanathan, a popular kind of book. So Ramu Ramanathan, he has already developed the coding of the Gretel code. Okay, and so I recommend you to be familiar with Gretel, because it is very user friendly. Okay. Now let us now consider greater. 1 minute, please.
Hello.
Hello.
Arindam sir, can you hear me?
Please.
Sir, one doubt I have. If in the model we have taken all dummy variables are independent variable, if we add some quantitative variables in the model, so the interpretation will be same.
Please repeat the problem in my audio. Please repeat.
Sir, my question is that in the previous model we only add that only qualitative variables D1, D2, D3. If we add some more independent variables in scale variable, so the interpretation remains same.
That means in addition to your regional variable, you want to add some other dummy
variables. Other quantitative variables.
Quantitative variable.
Yes.
No problem. Sadhvit, you are trying to employ your ANCOVA model. So ANCOVA model, that was just extension of your ANOVA model. Okay. So in addition to your dummy variable, you are adding quantitative variable. Okay.
Yes.
Okay, no problem. Interpretation will be remains the same. Interpretation will, now here, if you consider my earlier presentation, then we have included household size. Household size, okay. So size in a family. So in one family, it can be 4 members, it can be 3 members. So in one particular state, you can have one average family size. So average family size, you can have a data. You can have a data. Now, if you consider this particular data, this can be your quantitative variable. Okay.
Yes.
So in addition to dummy variable, you are considering quantity variable. Okay. And what is the interpretation? That if average family size increases, your consumption expenditure declines.
Yes.
Consumption expenditure declines. So this can be the interpretation for your independent variable.
Yes.
Household size. But interpretation of other explanatory variable. Interpretation of other explanatory variable like other dummy variable. They are remaining the same. There is no problem in interpreting the other explanatory variable.
Okay, sir, fair enough. That's clear.
Now, let us now consider. This particular software, Gator. Can you see Gator?
Yes, sir, it's visible.
Gator. Okay, this is one particular software. You can download this software. Okay, so I want to suggest you to download this particular software. Okay. Now in this software, now here, file, open, then now if sample file. Now if you click on sample file, now there is a huge data set. So if you consider the book written by Ramu Ramanathan, then there may be a data set on SAT score. Okay, if you choose these two variables, just enter. This is the variable list. Okay, so inbuilt. So in this software, we have an inbuilt data set. Inbuilt data set. Okay, so sample file. So in this way, some large numbers of a large pool of data set is there. If you follow the book written by Greene, okay, if you follow the book written by Greene, then in this book there is also some data set, financial data. In Gittel, they have also developed their own data set. Okay, so in addition these two books, here if you follow the tab Gittel, then you can have this data set. So just click on the data set. So they will asking you that you are going to open a new data set file. Okay. Okay, and then you are selecting this 4 data set and just press enter, then this data set is visible to you. Okay, so you can have a number of you can run a number of regressions or inbuilt data set is there. This is the particular novelty. there is another manual, user manual. Please consider this particular file, PDF file. It is actually your user guidelines. Okay, so if you click on this particular Acrobat Reader file, then one PDF will be there. Okay, an extensive coverage of the manual. Okay, so how can you do this particular statistical technique? How can you do this particular statistical technique? User manual is there. It is already inbuilt in this particular software. Now I want to open. I want to import a data. I want to import a data. Okay, so here Excel. So open, import Excel. Okay. Now, where it is? It is in my desktop data set. Okay. So they are asking me that already you have a data and you want to proceed with your new data. Okay, please proceed. Now they are asking for the sheet. They are asking for the sheet. Which one should I import? Which one should I import? Okay, there may be different. So whatever data sheet I have given to you, okay, it has different worksheet. These are the worksheet. Already you can find out this sort of worksheet. Okay, so so suppose and model. Okay, for the sake of simplicity, let us now consider ANOVA. So he's asking for so this is cross section. Do you have any time series or panel interpretation? So is it a panel data or is it a time series interpretation? It is a time series data. No,
it is a cross sectional data.
Only basically. So they are asking. So if you have a panel data, time series data. So if you have to click on yes, so they will ask you what is the starting time, what is the end time. Or if it is a panel data, they are basically asking you how many cross-section observations are there, okay, how many time series observations are there, and by multiplying n into t, they are actually tabulating your data set. Okay, so in this way, so here from model to ordinary least square, model to ordinary least square, you have to choose y. So just like SPS. So GTL very user friendly. There is no need to type the format. Very user friendly package, just like your user space, statistical package for social science. And now there is a change in the name, IBMR spaces. Okay, whatever it may be, forget about spaces. So I can be our regional variable, Y can be our dependent variable. Okay, then this is the same region. 654, 52 is the your mean consumption expenditure. That means here, if I can remember, then I stands for 1 for urban region, 0 for rural region. Okay. Now, if I is equal to 0, then only constant is there. That means 652 is the mean consumption expenditure for urban India. Okay, and I stands for I is equal to 1 for rural India. Okay, I0 is equal to urban India. So if you are moving from urban to rural, 0 to 1, urban to rural, then consumption expenditure declines by 278 rupee. Okay. So 652 is your urban consumption expenditure. Okay, because here I is equal to 0, and if I is equal to 1, urban expenditure, if you consider urban India, then you have to subtract 278 from 600. Then this can be the mean consumption expenditure for rural India. So in this way, you have to interpret, and they have their p-values. P-value that is highly significant p-values are there. So in this way, you have to do your exercise. Now here another point. Now here, choose Y, choose I. Now you want to remove constant. Okay. So by default, constant will be there. By default, it will be there. Okay. But you want to remove this particular term. Just remove. Yeah, remove. In this way. Okay, so in GitHub, please remember, in GitHub, you have to type the same command, regress y I, then comma, then non-constant. Non-constant. This is the basic command in GitHub. But here you have either you can add constant or you can remove constant. Very user friendly, very user friendly. No need to write any comment. So these can be without any constant. So in order to avoid dummy variable trap, sometimes you are using this sort of regression without constant. So these can be the these can be the pivot, these can be the your estimation. Okay, so this is all about GitHub. So so uh, so you this is very familiar package. Open source software. If you believes in open source software, I often believes in open source software. So in my research, I have extensively used GitHub. So if you believes in open source software, that means there is no proprietary restriction. I have the version, I have purchased, okay, and so I have an authority to use the software, and you have excluded, you have not purchased, and if somehow you have not any cracked version, hey, you have not stolen this particular software from somewhere else, so it is not possible for you to employ this particular software. So this is kind of proprietary framework is there in our research. Okay, so if you believes in open source movement, then try to familiar yourself with GitHub. This is my humble suggestion. Now return back to our earlier presentation. Okay. So I have given to you all of our result out. Now let us now move on to our difference in difference model, because as I have put, this is the nucleus of our discussion. Okay, difference in difference model. Okay. Now here, let us now consider difference in different regression. So as I have told you earlier, it can be shown by using graphs, by using graphical presentation, by using a box, or by using regression. So regression, very sophisticated technique is there. Now in this regression, suppose here we are considering one dependent variable, monthly per capita consumption. Okay, and two sources of variation is there. One is G. G stands for your treatment effect. Treatment effect. Suppose here we are considering rural India 1, urban India 0. Similarly, D. D stands for your temporal time differences. Time differences. D is equal to 1 for post crisis. D is equal to 0 for pre crisis. Okay, and then you have X. X is basically your interaction effect. This is very interaction effect. That means joint influence. That means joint influence of both your regional and temporal dynamics. So you are considering both regional and temporal dynamics in your regression framework. Okay, so you are considering an interaction effect. Just multiply the column. You have a column on urban India and rural India, regional variable. You have a column on pre-crisis, post-crisis. Okay, just multiply your G column with D column. Then you can have a separate column XIT. So these can be your interaction variable. Okay, and basically here in our regression framework, we have here time variable T 10, regional variable I, rural urban, and interaction variable. Okay, interaction, why it is very important, because it is nothing but your difference estimator. Why? Because here, if you put T is equal to 1 and I is equal to 1, T is equal to 1, I is equal, what does it mean? T is equal to 1 post crisis, I is equal to 1 rural. So rural consumption in the post crisis situation. Rural consumption in the post crisis situation. Then alpha plus, beta plus, gamma plus. So all coefficients are there. Okay. Now if T is equal to 1, I is equal to 0. T is equal to 1, I is equal to 0. So only alpha plus beta will be there. Alpha plus beta. Okay. So what in the post-crisis situation? What is the difference in rural and urban consumption? So you have to subtract alpha plus beta from alpha plus beta plus gamma plus delta. Ultimately, you have gamma plus delta. So this is one difference. Okay. Now, in the similarly, you can estimate these coefficients from our empirical specification. Okay, no problem is there. So, so in the rural India, this is the difference in consumption expenditure in pre and post crisis situation. In the urban India, this is the beta. Beta, what does it mean? It actually indicates the change in the consumption expenditure in the pre and post crisis situation for urban India. Then delta, what does it mean? Delta actually giving you the difference in differences. So one difference is beta plus delta, another difference is beta. Then what is your difference in differences? It is nothing but beta plus delta minus beta. Ultimately, you can have delta. Ultimately, you can have delta. So delta is giving you difference in difference estimated. Difference in difference estimated. Okay. So the intercept. So the coefficient of your interaction term is giving you difference in difference estimate. This is very simple. Okay, perhaps you have understood my logic. So this is very important. Why I am giving emphasis on interaction variable? Because the coefficient of the interaction variable, this is your interaction variable, and the coefficient of the interaction variable is actually giving you a measure of DID estimate. A measure of DID estimate. Okay, so the delta is nothing but your measure of DID estimate. Okay. Now here here in our research we have employed DID estimate equation. Okay, and one set of equation, one specification for uniform reference period, another specification for mixed reference period. Okay, so two separate equations here in this table. We have represented two separate equations. So so first equation is related to uniform reference period, that means that data consumption expenditure measured by mixed reference period. Another set of equation we are considering mixed reference period. Okay, so these two are regressions. These two are regressions. Okay, now here what we have found actually in our result, only there is a significant impact of regional I. Constant is significant. Forget about constant. Only I is significant. Only I is significant. Right? So here in our equation, what we could find out that there is a difference in rural and urban consumption expenditure. So difference in rural and urban consumption expenditure is statistically significant. Okay. The impact of crisis is not significant. It is not significant. So T statistic, it is not significant. Okay, very low statistic, very low value. An interaction term, it is also not significant. It is also not significant. So what is significant is that of only your regional variable. So rural and urban, in the rural and urban region, there is a significant difference in the consumption expenditure. But crisis, even though crisis has an impact, as I have told you earlier, that with the help of our table, we have shown you that the crisis has impact, but the effect of crisis is not statistically significant. Impact is there, but impact is not statistically notable, statistically significant. Okay. Now, so this is your regression result. Now, from the regression result, actually, if you want to estimate average monthly per capita level of consumption in rural and urban India, average monthly per capita consumption expenditure in rural and urban India, okay, then you have to use some sophisticated statistical practice. And in Stata, it is already there. Okay, I shall show you later on that how can you use Stata in order to estimate average monthly per capita consumption expenditure. That means from regression output. So this is the regression output. From regression output, how you can return back to your table. How you can return back to your table. Okay. So please remember, this is my table. Okay. So this is my table. So what is the average consumption expenditure in rural India in post-crisis situation? What is the average consumption expenditure in rural India in the pre-crisis situation? What is the average consumption expenditure in urban India in post-crisis situation? What is the average consumption expenditure in urban India in pre-crisis situation? So these average values, you can estimate. You can estimate if you have any statistics. Otherwise, manual calculation is also possible. I shall show you later on. So, from regression, you can return back to your table, original table, and you can have your average level of consumption. Okay, and you can find out the difference. You can find out the difference. Then in the uniform reference period, what is the value? Different DID value 31.6. Okay, 31.6, and here also 31.7. Same thing. Please remember what I have said once. That the coefficient of the interaction term. What is the coefficient of the interaction term? Delta. Please remember. Delta is your coefficient of the interaction term. And delta is giving you the difference in difference estimate. Delta is giving you difference in difference estimator. Please, match the same logic in the light of our real life data. In the light of our real life data, at first we have estimated regression. From there, we have estimated coefficient of the interaction term. It is 31.7. Same value is also calculated. You can also calculate the same value if you use a particular table. Okay, and same thing 33.7. If you use mixed reference 33.4. Here also 33.7. Same sort of maximum variation, but idea is remaining the same. Idea is remaining the same. Okay. Now we have actually faced a comment. Actually, one of the reviewers they made a comment that you are doing this particular regression with an observation of with 40. Okay, so for uniform reference period, you have only 40 observations are there across decile class. Please remember, across decile class, there is a limitation of observation. So across decile class, you have only 40 observations here, and for mixed reference period, you have also 40 observations. So limited number of observations are there. How can you increase the number of observations? So this is also possible. So I have this sort of comment, and so we want to address the basic issues, and so we have chosen one method, another control. So this is the control. So we have used another control variable, M. M stands for method dummy variable, and M, okay, it is equals to 1 if you are using URP, uniform reference period, and it is 0 if you are using mixed reference period. Okay, so if you add one, sorry, if you add one dummy variable, method dummy variable, okay, then you can club the observation. Then altogether you can have 80 observations. Please remember. Let's try to understand my logic. So they have given me a comment. Reviewer, they have given me a comment that you have only 40 observations in this equation. You have another 40 observations in this equation. Okay. How can you club? So again, dummy variable, by using dummy variable. Okay. This is our way to address the problem. Okay, so we have introduced a new dummy variable, method dummy variable. It is equals to 1 if you are using URP. It equals to 0 if you are using MRP. Okay, so then 40 plus 40, all 80 observations you can have. Okay, so you can have an exhaustive data set of 80 observations, and you are doing the same regression, okay, okay, but the regression output is to some extent it is exactly remains the same. That means the logic is remains the same. Okay, that means here also only our regional effect. This is our aggregative result. In the aggregative result, our regional effect is only statistically significant. Okay, time impact is not statistically significant. Interaction term not statistically significant. Method of that method variable it is not statistically only regional variable. So whatever we have found in our earlier result, the same result is also replicated here. The same result is also replicated here. Okay, but here the result is to some extent robust. Why? Because number of observation is high. Now from this table also, if you combine your data set on URP and MRP method, then you can have this sort of table. Average value. Okay, combining both the method, what is the average value in rural India and urban India? In pre-crisis and post-crisis situation. These are the average value, as I have told you earlier, that by using statistical software, you can calculate, or you can manually calculate, no problem. Then from there, you have considered differences, and we have estimated difference in differences. Okay, difference in differences. Okay, and DID 32.5. This can be your change. And here 32.5. Here, please identify that the coefficient of your interaction term is nothing but your difference. Okay, so as I have told you earlier, that you can match with the difference in different estimator is exactly your coefficient or not. Okay, so if your conceptualization is correct, then obviously there will be a match in these two estimators. Okay, now let us now use stata again once. Okay, stata is there, and if you consider my worksheet, DID, we have one worksheet DID. Please open DID worksheet. Then you can find out these particular. This is the data set. 80 observation. So I have a pooled that means combining both URP and MRP. Okay. Variable name. Sorry. At first, new. Then just test it. First one again. TI. So please remember that T stands for your pre and post crisis situation. Y is your average consumption expenditure. MPC, monthly per capita consumption expenditure. Across decile class. Please remember across decile class. So on consumption expenditure we have a vast detail. But if we consider consumption expenditure across decile classes, then we have limited literature. Okay, so we have done research on across decile classes. This is the basic research gap we could find out. Okay, forget about research gap. Concentrate on the software. T stands for your dummy variable time, and I stands for your urban and rural India. So this is the variable, and TI is nothing but the interaction variable. T multiplied into I, interaction variable. Okay, and M stands for the method. The first one URP, and the second one there MRP. So in this way, so we have a pool data set of 80 observations. Okay. Now we want to run the regression. Okay. equation y I ti. Okay, the name and the same equation. What I have shown you earlier, the same equation is also there. In fact, I have copied from here. So the equation output is there. Okay. Now, as I have told you earlier, we want to find out average value. We want to find out average value. Okay. Please remember that if you want to tabulate the data, okay, then average value. Suppose we are interested in average value. Okay, we want to return back to our table. Then this is the comment: collapse mean. That means, what does it mean? Please understand the comment. Collapse. Why should I write collapse? Collapse. That means mean. Sorry. Meanwhile. Sorry, no. Mean within bracket constant. Meanwhile. If there is a problem, like any problem, there's a dot or any other kind of problem, this software will not work. Please be cautious in writing comment. Okay, so exactly you have to type this one. Meanwhile, okay. So actually, what does it mean? So Y stands for, if you remember that Y stands for NPC, monthly per capita consumption. Yet you are trying to calculate mean or the average MPCE in rural urban India. Average MPC in rural and urban India in pre-crisis and post-crisis situation. So you are collapsing mean. So you, from the whole data set, you are trying to identify the mean value. Okay. So mean collapse mean by, and then by. That means you are considering two categories. So write by within bracket ti. That means by t and by I. What does it mean? There must be comma, one comma, separated by comma. Okay? So try to understand the logic behind writing this particular comma. So you are actually calculating mean value of y. Okay, you are trying to calculate mean value of y, the mean average, that means average monthly per capita consumption expenditure. Average monthly per capita consumption expenditure. You are trying to calculate. Okay, by two different categories. By time, pre-crisis, post-crisis wise, you are trying to calculate, and by rural urban India, you are trying to calculate. Okay, so by T and by I. Okay, please try to understand. Then, by within bracket does not contain a valid variable. We have a variable T and I. Okay, T and I in our data set. Please let us now check. T is there, I is there. T is there, I is there. So collapse meanwhile. Oh, there may be a problem with space. What is the problem? Oh, sorry. So please. actually. Collapse. Oh, yeah. Oh, sorry. Actually, no. And they have considered TI, but interaction downwise, they have given the result, but it is not our basic intention. So basically, so in this, there is a problem. Okay, so please try to. Okay. Okay. So here, now there is a problem. I could not find out the problem. It is not possible to solve. So repeatedly, I have to verify. Basically, this is my, in my exercise. I have what I have written: collapse mean y by t into I. T comma I. What does it mean? What does it mean? T, oh, sorry, no comma. One second. One second. Please. Sorry. One minute. Okay, so I request you to do the exercise. In fact, in my earlier presentation, or what presentation I have prepared, there I have written collapse within bracket mean y by t and I. So by time wise, they are giving the data, and by region wise, they are giving the data, and these are the mean consumption expenditure. These are the mean consumption expenditure. Okay, so so in the data set, please consider that this is your new data set. Data editor. At first, you have copied the data from Excel to Stata data editor. Okay, and there they will produce the result. They will produce the result. Okay. Okay, in the data editor, they will produce the result. Please remember. So if you type the command, there is a problem in my typing. Okay, so I could not find out the correct command. Okay, so please try with yourself. Now, if there is if you could correctly type out the command, then the data editor shall produce you this value. There will be if T0 I0, T0 I0, this is the mean expenditure. Okay, T0 I0, what does it mean? I0 stands for urban, T0 stands for pre-crisis, then 684. In this way, if I 11 means post-rural. Okay, so they will produce this information. Software, they will produce this information, and if by using this information you can prepare a table. Okay, so this is the comment. But if you do not have any stata, then there is also no problem. You can do the similar exercise by using data. Okay, so just choose time variable, space variable, time into space variable, method variable. Okay, so TI, actually there is a problem in understanding it. What does it mean? So you have to write down time. So you have to specify the variable. Okay, so time into space, yeah, method. So the same result is also there. But in here, average effect, you can calculate your average effect manually. You can calculate your average effect manually. No problem is there. So if you sort out the data, if you do not understand the command, collapse command is not going to, or I am now facing a problem in writing collapse command. Okay, then what is the way out? Way out is that. Way out is that. So you have to sort out the data. So sort out the data. So we have two dummy variables, one for time, another for region. So if you sort out the data 0, 1, 1, 1, here 0, 0, 0, 0, 1, 1, 1, 1. Okay, so 0, 0, 0, 0, that means urban pre-crisis urban situation. This is the mean. Oh, sorry. This is the mean. 684. 684 is the mean. Then here, then post-crisis urban India. This is the mean 690. In this way, okay. So as the site here, we have a limited space here. So we have shown you two figures. But in this way, you calculate 0, 0, 1, 0, 0, 1, 1. So already you have sorted the data. So from 0, 0, what is the mean value? So this is the mean value from this observation. Just here, put your cursor here. Just write mean value. Just write mean value or average. And this is the set of observation. This is the mean value. This is the mean value for these other set of observation. In this way, you can prepare this table. You can prepare this table. No problem. Manually it can be done. But there is an easy comment, but somehow I am writing a mistake. Now, let us now introduce another topic: structural break. Structural break. Now, structural break. Now, here there is a abruptly change in a particular point of time. That means we have a relationship. Suppose we have a relationship. We have a relationship, and suppose this is a relationship, and we have a pool data. We have a pool data, and from the pool data, we have estimated a single equation. Single equation. This is the relationship. This is the relationship, and in Wales regression, if we have a full sample, then Wales regression, we assume that we are maintaining the relationship over the time period. Okay? So the relationship actually is maintained over the time period. So we have a time period here. We have a time period here. So over the time period, the same relationship is maintained. Over the time period, same relationship is maintained. But here that means the intercept and slope shall remains the same. If you have a single relationship, single equation, by using a single equation, you are estimating the relationship. Okay. Then over the time period, over the full time period, you assume that your intercept and slope, your slope and your intercept do not change. It do not change. Okay. This is your assumption. Okay. But in our real life situation, this can be a tall assumption. This can be a tall assumption. In real life situation, there can be variation. So if you consider two subsamples, so suppose here we have a subsample. So before 1990, what is the situation? These can be the trend. So these are the scatter plot. So suppose pre-liberalization, these can be the trend, and after liberalization, these can be the another trend. Okay, so if you considering a whole data set, 1970 to 2020, 1970 to 2020, okay, you are estimating a relations. You are estimating a relations. So what is your assumption? The same relationship will remain the same. That relationship will remain the same. in the long time duration. But if you consider two subsamples, one from 1970 to 1990, another one from 1991 to 2020, okay, then there can be a change in the relations. So pre-liberalization, there can be this, in this way there is a change. Post-crisis, there can be in this way there is a change. Okay, so that means that if you consider subsample, then there can be a change, structural. There can be a structural change. Okay, so so average regression relationship can be quite different from the true regression function. If you consider two subsamples, and from that, if you calculate the true regression function, then it can be different from the one single regression. Okay, so there may be a problem. There may be a problem. So you have to consider some of the changes, discrete changes. Discrete changes, that means here, if you consider the collapse of our Bretton system, or there is a evaluation, slow evaluation of economic policy, and ongoing changes in the structure of the economy. Okay, so this can be your slow evaluation. So there can be a drastic change, discrete change, drastic change, okay, or there can be a slow evaluation. That means the effect is realized after a successive period of time. So in both the situation, you can employ chow test. You can employ chow test in both the situation. Okay, so in order to identify discrete change, or in order to examine your slow evaluation. Okay, so policies, they cannot be that the impact of the policy cannot be realized in the next one. It can take 10 years to realize the impact of the policy. Okay, so slow evaluation can be there, or there can be distinct change. Okay. In both the situation, you can employ chow test. There can be other tests. Now, if your debt is known to you, then you can chow test. Or if the debt is not known to you, then you can employ modified chow test. Okay, so chow test is employed when the debt, that is when this is your liberalization. 1990. This can be the point of liberalization. Okay, so date is known. If the date is known, you can have chow test, or if the date is not known to you, so I have no such prior information. Okay, so let the software calculate some of the break dates where there is a structure change. Okay, so if you allow the software to identify the break date, okay, then you have to employ modified chow test. So due to the lack of time, let us now directly consider the application. So basically, here I have given you this particular data set, sustainability of microfinance institutions. So ongoing, so I am now doing a research. In fact, one of my scholars is now doing a research on sustainability of microfinance institution, and it has many dimension. A multi-dimension concept is there. So forget about multi-dimension aspect of the problem. Let us now consider what is our ultimate result. So this is our ultimate result. Somehow we have calculated sustainability score. Okay, so these are nothing but a sustainability score, and these are nothing but a microfinance institution. Okay, Odhikar, Asumi, SKS, PSFL. So these are basically microfinance institutions. Okay, and basically here in this paper we want to examine the impact of Andhro crisis. So Andhro was if you remember the crisis, it was the epicenter of the crisis. It was started in the year 2010, mid 2010. Okay, so Andhro crisis. Perhaps you have heard the term Andhro crisis. So it may have some impact on the sustainability. This is my basic quantum interest in this particular research. So we at first what we have done, we have estimated sustainability score. So from the mixed database, microfinance information, we have collected the data, and from the data we have measured our sustainability score. Okay. Now for one particular, so just concentrate on one particular microfinance for Odhikar. This is one particular microfinance institution. Okay, so for one particular microfinance institution, so this is your data set. So in the stata, you can have you have to import this data: year, time, and score. So time 1, 2, 3, just starting from one. Okay, so in this way you have to write down the time. Okay, these are the score. So we have collected only these portion, only these portion, first three columns. Okay, so we have imported the first three columns in the stata detector. So here, this is the variable. Then you have to regress. You have to type this command. Regress score time. So score is your dependent variable. Microfinance sustainability score is your dependent variable. Time is your independent variable. Okay, score is your dependent variable. Time is your independent variable. Because you do not have any information, and you want to examine what is the impact of Andhra crisis on the sustainability. On the sustainability of microfinance institutions. Okay, so at first you are considering this equation: score. So score, microfinance score, dependent variable, time independent variable. This is the result output. Okay, this is the result output. Now here, here, suppose I have a prior information that Andhra crisis took place in the year 2010. Okay, so 2010, so up to 2009, there was no problem. So this is the before crisis situation, and after 2010, there may be a problem. So here, time period 5. Okay, there is no problem, and time greater than 5, there is a problem. So I have information. So if I have a prior information, I can employ chow test, as I have told you. Okay, so time greater than 5, this can be break. So generated break, they will actually calculate in time variable for you. Okay, so automatically they will calculate. If you write down this particular comment, generated break, okay, time greater than 5. So for time greater than 5, so 6 onwards, okay, they will tabulate you 1, and for less than 6, then up to 5, they will 0. Now, it is one particular dummy variable. They are actually tabulating one particular dummy. Pre-crisis, post-crisis. Okay. Similarly, you have to multiply. You have to generate another variable. Break into time. Okay. So this is in methodology. So methodology, you have to you have only time as an independent variable. Okay, you have a time only as an independent variable. So you are multiplying break into time. So this is another variable. So break into time, just break into time. 1 into 0, 2 into 0. In this way, they are considering another color. Then this is the ultimate result. This is your ultimate result. This is the F statistic. Okay. And then sorry. So after having 2 additional columns, okay, you can run this regression. Regression score, time, break X, break into X. So break into X is nothing but the interaction. Okay, break into X. Okay, so then this can be the result. Okay, then write down comment test into break X. Okay, then they will produce you the value of F statistics and associated with the level of significance. 4.44 is the F statistic, level of significance 0.2. What does it mean? So ultimately, what does it mean? If it is significant, then there is a structure. Okay, so under null hypothesis, we assume that there is no structure. There will onthro crisis. So think about our research. Then onthro crisis have no impact on these microfinance institutions. We are considering one microfinance institution, Udhikar. Udhikar is our microfinance institution. So for Udhikar, this is the A value and this is the P value. P value is significant. What does it mean? Our null hypothesis is rejected. What is our null hypothesis? No structural break. So no structural break is rejected. So ultimately, what is our conclusion? There is a structural break. That means onthro crisis has an impact on the sustainability or sustainability score of Udhikar. So for this particular microfinance institution, onthro crisis has an impact. Similarly, we have done similar exercise for other microfinance institutions. Okay, so we have a large microfinance, and out of 26 or 27 microfinance institutions, only 7-8 microfinance institutions they have shown an impact. They have shown the impact, and from there we have carried out our next research objective. That how can you explain their impact? How can you explain? Okay, so significant value. So significant value, what does it imply? There is a structure. Okay, so onthro crisis has an impact. It has a structural break on the relations. So pre-onthro crisis situation is to some extent different from post-onthro crisis. Okay, okay. So this is our overall result. This is our overall result. But here we have only one variable. Now, if you consider our relations, in our earlier example, we have only sustainability score. But if you have a relationship be in between GDP, US GDP and Japan industrial production, Japan. So there may be relationship. There may be relationship. And in this, we want to examine whether the relationship is stable. Whether the relationship is stable during this time period or not. Or is there any structural break? Is there any structural break? Okay. Now, for this purpose, we have done the similar exercise: regression, GDP, Japan IP. Okay. Then we have generated 1975. 75 is the period relating to Bretton Woods conference, collapse of Bretton Woods conference. These can be the structural break. I have some idea that these can be one such point, one such distinct point where from there may be a change in the relations. Okay, so I have intentionally specified t greater than 73 as a dummy variable. Okay, then break into x. But ultimately, what is the conclusion from the F value? No, yes, it has an impact. Highly significant. Highly significant. That means okay, structural break. It took place in the year 1975. In the year 1975. Okay. Now, alternatively, suppose these can be some comments. Please do your exercise. Yourself. I have limited time, so but I have given you all such materials. Please type TS set time. This is the comment. Same data set. We have the relationship between US GDP and Japan industrial production. So altogether, we have 227 observations. We have 227 observations. But what is the problem? Suppose we do not have any information that where structural break took place. If we have no prior information, then we have to at first apply modified job test. We may not have any idea on the break date. This is unknown break date. For unknown break date, we have to use modified job test. Modified job test. Okay. Now 1 to 227 observations are there. Okay? A long time series data is there. Okay. We have no information where the structural break took place. Okay. So basically, computer software, they will this is the data output. Computer software, they will identify the break date. That this is the point 167. This is the point where there is structure 167. So this is the point where there is structure, and this is if you consider the particular data set. Okay, then in this particular point 167, 167. Okay, so we have done the by considering this particular break date 167. So please remember that 167 is the particular data point where the structural break took place. Okay, so you have an information that it is the date where the structural break took place, because you have no information. Okay, you have at first you have employed modified job list. Then at 167, is there any structural break? So now the date is known to you. Now you are doing the similar exercise. So this is basically your comment. This is basically your comment. So break date is known to you, 167. By choosing the break date, so it is known to you. Okay. Now you are doing similar exercise. Then it is highly significant. That means highly significant means no structural break. It is rejected. Your null hypothesis is rejected. So there is an evidence that there is a structural relationship. There is a structural break in the relations. And by using Gradle also, you can do similar kind of exercise. You can do similar kind of exercise. At first, you have to input the data. Then same regression. Score is on the dependent variable. Time is the independent variable. Okay, regression output will be there. Then from test to chow test, it is there. Test to chow test. After estimating the regression, then you have to choose test to chow test. Then you have to specify the date where you want to split the sample. Very interesting. Where you want to, that means your date is known to you. You want to employ chow test. Date is known to you. You want to employ, and I have specified 2010 because this is Andhra crisis, time of Andhra crisis. Okay, so this is the test point where I want to split the sample. So I want to have now two different subsamples. Okay, so 2010, then okay. Specify the time period, then okay. Then they will produce the automatically. They will split the sample, they will produce the figure, and this is the figure. The same thing, same value which you have obtained in the stata, the same value is also reproduced here, 4.44, and it is highly significant. So the same table you can have by using your stata. Okay, so so these are, and I have given you some of the selected selected pages from this particular book. Stock and Watson, they will be very well known book. Very well known book. Basically, different estimation. DID. This is you cannot familiar this particular topic in other econometrics. It is not there. It is not there. DID is not there. Okay. But it has some extensive application. So if you consider this book, Introduction to Econometrics, then you can find out this particular topic. And I have given you the material, original material. This is the PPT is just a skeleton version. It is just the skeleton version. Okay. So the whole material. So from the book, I have given you the particular pages, the relevant pages. I have already sent to you. Already sent to you the book, selected portion from this book. This is a very interesting book. Okay, so structural break and stock and for different, you have to consider this particular book. And from Malhotra, if you consider Norris Malhotra, then you can have some idea of experimentation. So for the first portion of my discussion is from Norris Malhotra. Then Gujarati is one particular book from ANOVA and Cuba model. For this purpose, you have to consider Gujarati. And these are basically some of the PPTs prepared by the faculty members of Princeton University, DID and time series. You have to consider this particular PPT, and these are basically stat application. These are application, an extensive application of stat. Okay, so this is all about my presentation. I want to stop here. Now, if you have any query, a short clarification, then you can ask me, or if you want to employ this particular technique in your research, you can directly contact me. This is my email. Second one, second one is basically my institution email. Okay, so you can contact me. So at first you have to introduce that I have participated in this particular program. This is my research program. How you can solve the problem. So in this way, at first, please Introduce yourself at first, and then write down the text, your research problem. Then I shall try to address, if my understanding, based on my understanding, I shall try to solve your problem. Okay, so I want to stop here. If there is any quick explanation, please ask me. No problem.
Thank you, Arindam. The participants who are having any doubt and who want to ask a question, the dais is open for all of you. So please go ahead with your questions if you have any doubt and queries.
Can I say, ma'am, something?
Please.
Yes, yes.
Sir, I am really grateful that.
Is it audible?
Oh. Hello, am I audible?
Audible, perfectly audible.
Yes,
Sir,
yes. Please go ahead.
Sir, it was a really nice session you have taken. I have a lot of things to learn from you, but you have taken from morning to whole session. I have listening very mindfully and online sessions, and it's a really wonderful. You have clarified on dummy variables, lot of doubts on structural break also. It's amazing. You have explained it nicely with the data set and study material also relevant to that what you have discussed. It's nice. Really, it's amazing. From core of my heart, sir, once if I've given more session to you, it will be enlightened again and again. Thank you, sir. Very much happy, sir, with your sessions.
Thank you for your nice comments. Thank you, participants, for your nice comments.
Thank you, Devi sir. Yes, thank you so much. Yes.
Thank you, ma'am. Thank you.
Actually, Arindam sir's session was very significant. Friends who have listened or attended this entire session very minutely, like Devi sir, please come forward and share your comments with us. Is there anyone else who wants to interact with sir? Haldar sir, are you there?
Hello.
There is another. Yes, Haldar sir. Yes.
Pallavi madam. Arindam sir का जो lecture रहा है,
हाँ जी sir.
very nice, very informative, and his way to explain the all such things are ultimately like our previous experts have. For the same, many thanks to sir, and many thanks to your organizing committee. Thank you very much.
Thank you, my participant.
Thank you, Haldar sir.
Ma'am, one request. You also allow us.
Sir.
Ma'am, follow ma'am. You also allow us to participate in the third FDP. We became interested to listen all these things, and really we're also delighted to. No, it's a good session, ma'am. It's really brought up the concept. Thankful to all of you because it's wonderful resource person.
Thank you, Devi sir, and you would be very happy to know that Arindam sir, as he said, he was with us in phase 1, and he is here, and he will be in phase 3 also. So he'll be there in phase 3 also. So yes, Devi sir, if that would be possible, definitely with your request, we'll be letting you attend the session. And then again, so that you can have a lot of significant results from it. We also have comments, Arindam sir, from SK Mujibar, and he says it's a very nice session. We have a chat from Gaurav Panja, and he said it's always a pleasure to listen to you and knowledge provoking. So I think we are getting very nice comments. Thanks to Haldar sir and Devi sir for sharing their comments. Anyone else wants to interact with sir right now? The dais is open. Okay, I think then we should now end the session officially. Arindam sir, if you want to say anything, you can, you can just interact right now, and then we'll go forward towards ending the session formally, and then towards the test.
Okay, thank you, Pallavi and other organizers. It is really a nice experience to share my some ideas on this particular topic. So if there is any further communication in my mail, if the participants they are trying to communicate their research problem, then I shall be happy to address their problem. If, depending on my capacity, I shall try to address their communication. Okay. So thank you all. Thank you. Nice experience. Thank you.
Thank you so much.
Now I am leaving. I'm taking permission from the organizer. I want to leave.
No, not now. Please wait for 2 minutes. Arindam, for 2 minutes. Yes, for 2 minutes. On behalf of the entire organizing committee, I really want to thank you from the bottom of my heart for accepting our invitation and taking a remarkable session on day 6 of STTP on Econometrics Phase 2. The way you explained dummy variable, its role in estimating various ANOVA and ANCOVA models, also the application of definitive, working on stata, interpreting the results, also the structural break, everything was phenomenal. You are also a resource person. You were in phase 1, in phase 2, and you will be in phase 3. And I cannot express my gratitude through mere words for giving us your valuable time. Thank you so much. Arindam sir, thanks a lot, and thank you so much for joining us today as our eminent resource person in this particular phase of STTP. We are looking forward to more of your sessions in phase 3 and also in more workshops in the near and the far future. I hope this connection and this collaboration is a long-term one, and we are really happy to have you with us today. Thank you so much.
Thank you. Thank you, Pallavi. I am also enjoying your association. Okay, so all of your members at the IPS Academy, okay, they are so humble. Okay, for inviting me. Okay, I have really enjoyed a lot.
Thank
okay.
you.
Thank you,
a lot. Thank you. And thank you for your PPT. It is shared with all the participants, and your data was shared.
Please share the material. Some of the materials, whatever materials I have given to you, please upload the material for the sake of the participants. Okay. Thank you.
Thank you so much. Thank you.
Thank you.
Dear participants, I now hand over the mic to my colleague, Dr. Sunita, and I think she is going to tell you more details about the examination right now after this. And if you have any queries or concerns, the dais is open for all of you to discuss with us.
Hello.
Sunita, please proceed.
Good afternoon, participants. Thank you so much for your kind support, and thank you so much for associating with us. And really, you has done a great job. Majority of people, they has given their all kind of involvement. I would like to say my thanks to couple of people like as Pratik sir and Haldar Sharma sir and Sunita Ramchandani ma'am, Neha ma'am, and other people. Really, you people has interact a lot of time with a resource person. Now it's a time to ending our econometrics journey for the phase 2. Your examination, we are going to start by 2:30. We are going to share you the one web link that is safe and with the help of passcode. So you can link and you can click and you can give your examination. You have only one attempt allowed, and the examination time will be 60 minutes. 50 questions will be there. And please, we are giving the two more simple question, which is based on the name and organization or institute name. Whatever the name and your institute name you are going to write over there in in there, please write down your name in a capital and the organization name also in a capital. Same thing we are going to apply in your certificate also. In this form, I feel that like as you will not face any problem related to your spelling or institute name in your certificate. There will not be any kind of changes after giving your name and organization name in that particular question. Okay, this particular examination link will be open till 11 p.m. Again repeating, this examination link will be open till 11 p.m. But suppose you have login for this examination link near about 4 p.m. So that examination link is going to finish by 5 p.m. After that, you cannot apply again. You can attempt, you can take only single attempt. Meanwhile, if you are facing any problem, so please let us know. We have share our numbers also. So the any kind of problem you are facing, so you can talk to us. But again, we cannot give the permission like as to go for second attempt or third attempt. That kind of permission we cannot give you. And there are the certain kind of condition by the AICT. You have to score some minimum marks near about the 60% that you have to fulfill with the help of attempting that particular test. This test detail we are going to share within a half an hour at your email. And even we are going to inform you on that particular WhatsApp group also. Now, I request to Sachin sir, please summarize this entire phase 2. And me after the Sachin sir, I would like to request to the participant kindly share your views and share your suggestions and which we can incorporate in a phase 3. Thank you so much, Sachin sir. Over to you.
Thank you, Sunita ma'am. Am I audible? Sunita ma'am, am I audible properly?
Yes, sir. Yes, sir. You are audible.
Yes, sir. You are audible.
Yeah. Dear participants, before we move on the final vote of thanks, we would be happy if you share your informal feedback. Of course, the formal feedback you can submit through the link, but we will be happy if you share your views, your actual feedback with us. So we will be happy to improve further in next phases. So whatever view you have, we will be happy to listen you. Whatever views, or if you have any suggestion for the further improvement, we will be happy. You can share with us.
I request to Pratik Tripathi sir, please say something about our session and like as you want to share your experience, so you can share Pratik sir, because you was one of the most active participant of this particular STTP.
Devi sir, do you want to share your views with us?
Hello. Good afternoon.
Yes, Devi sir, you are audible. Yes.
I request to Halda Sharma sir.
Hello, am I audible?
Yes, sir, you are audible.
Madam, whatever the STTP you are organized here, really it is the value for the researchers. Those are having any kind of the bottleneck in their research paper.
Halda sir, your voice is very slow. Can you increase your voice?
Now it is audible.
Yes, you're audible, sir. Please.
Okay. Audible now,
Yes,
clear?
yes, you're audible, sir.
Yes.
Please go ahead.
Yes, your STTP
Anji,
organizing
yes,
committee has organized a wonderful STTP. All your speakers, like guest speakers, those have taken the lectures, explained everything in detail which is required for the participants. They have given each and every explanation why we are using dummy, why we are having logit. Yesterday's lecture taken by the Gupta sir, extremely very wonderful. All are wonderful, but I could recall, yes, going back one by one back. Today is the 6th, yesterday was the 5th day. So what he has explained everything. Really, a researcher need all such things. So that a researcher is able to take some kind of the good changes in the research paper, and even those are pursuing their PhD, they are also be very much benefited with this workshop. Many thanks to you, and my suggestion to you that whenever you are selecting the guest speakers, you have to convey to them in the same manner what you have this whole session lectures. Convey to them that you have to be having the PPTs, you have to be screen share, and you have to be give the detail of everything. So it is very good that you have given the ample time to each resource person from 10 o'clock to 4:30 o'clock. So in that manner, a speaker is very much efficient in able to convey the all things which he or she likes to convey. For that, many thanks to you, Sachin sir, Pallavi madam, and Sunita madam. मैंने सभी का नाम सही बोला है क्या? सुनीता मैडम सही बोला
Yes,
मैंने आपका
Dr.
नाम?
Haidar, all the names are correct.
Yes. याद हो गए तीनों नाम. Thank you very much, and expecting same in near future whenever we conduct the same kind of the workshop. So I will also try to my best. I will also join in. Many my other friends, those that are working in the same area, econometrics research paper, they are also preparing. I will also convey to them, join this workshop and work together. Once again, many thanks to you, your organization, your director, that is the Kushwaha sir. Thanks to him also that he has permitted to you all to conduct all such things, and also thanks to AICT that they are sponsoring such kind of the workshop, because if we are paying such kind of the workshops, it is very highly cost. So they are giving to some kind of the aid. Due to that, the participants are very willingly, very liberally, they are able to join. Once again, many thanks to all those are not here counted by me. Everyone, many thanks. Thank you.
Thank you, Haldar sir. Thanks a lot for your significant comments. And yes, your association has been really valuable to us. Thanks a lot for sharing your views. And yes, we are very pleased and happy for AICT who sponsored this particular program and then gave us the permission. And of course, we would like to thank our director, Dr. Vivek Kushwaha sir, to allow us to conduct such a STTP. And yes, now like carrying this forward, the comment session, Devi sir, Pratik sir, if you want to share some comments, please, the dais is open.
Dear participants, one more from our side, we are going to share the 6 YouTube link. This entire session of the last 6 days we have share on our IBMR IPS Academy YouTube channel, and the entire this YouTube channel and the entire
Hello, Madam Sunita Madam.
on the link we are going to show the if on some part you have skipped some part you have skipped due to any reason, you can recall like
मैडम
as even you
दो माइक एक साथ चल रहे हैं मैडम, दो माइक एक साथ चल रहे हैं.
recall all things. Okay, so that is a gift from our side. Like as majority of participants, they were requesting for the recordings and other things. So that kind of recording we are going to share from our side. And even apart from the econometric STTP, we have uploaded our all videos which has been associated to the management 4.0 and financial analyst. You can like as you can visit our this YouTube channel, and you can see a lot of activity whatever we are conducted in a previous time, and even we are going to conduct in a future. You can see all kind of videos, knowledgeable videos and informative videos. So thank you so much. Over to you, Sachin sir.
Thank you, ma'am. Dear participants, thank you very much for joining this program. No workshop can be success without the participants. You all are our participants in this workshop. It's indicate that you still have a zeal of learning. You have still want to improve your knowledge. I hope this workshop really improved your knowledge, improved your overall econometrical knowledge, and I hope that this is really a value addition, this workshop, in your overall knowledge. Thank you very much from the bottom of heart for joining this workshop, attending regularly this workshop, and making all these sessions interactive. I would like to express my heartfelt gratitude to all the resource person, Dr. Ganesh Kavriya, Dr. Karunesh Saxena, Dr. Kulveer Singh, Dr. C.P. Gupta, Dr. Arindam Laha, Dr. Preeti Sharma, who have shared their valuable knowledge with us. Not only valuable knowledge, these persons, these resource persons are very, very busy persons, but on our simple request, they have accepted our invitation and shared their valuable time with us. I would like to also thanks to IBMR IPS Academy, all the faculty members and staff members who have supported directly or indirectly in this workshop. Dear participants, this 6 days workshop, it's not an easy job. There is a lot of teamwork. So our faculty members, our staff members have supported directly and indirectly. I express my sincere thanks to this dedicated team, Dr. Sunita, Dr. Pallavi Mukherjee, and Dr. Tarika, who have worked day in, day out to make it success this workshop. I would like to express my sincere gratitude to AICTE, who is the sponsoring authority of this workshop, for their all support. We are highly thankful to AICTE. At last, I would also express my sincere gratitude to our director, Dr. Vivek Singh Kushwaha, and President Architect Achal K. Chaudhary sir, who has given all the resources to conduct this workshop, and for their faith, for their trust, and they have given this assignment to us. So thank you very much to everyone. I hope you really enjoyed this workshop. In case of future, if you want to continue this session, if you want to re-attend, all these sessions are uploaded on our IBMR IPS Academy YouTube channel. You can access all these lectures again for your practice purpose, for again improving purpose. You can refer it. Again, I am suggesting you please note down our YouTube channel, IBMR IPS Academy. You can log in on YouTube, you can access our YouTube channel, and you can access all these lectures in future also. Also request you, we will forward you other. We have 2 more STTPs. One is on management 4.0, another one is on financial analytics, and we have also third phase of econometrics. So we will forward these brochures in this WhatsApp group as well as on your email IDs. So please suggest your colleagues, if anybody is interested, they can register for remaining econometrics phase 3 as well as in other 2 workshops on financial analytics as well as on the management 4.2. Again, we assure you that we have invited the best resource persons across the India, from top-notch institute, top-notch faculty members are the resource person in our all 3 STTPs. So request you please forward it. If anybody is interested, our links are open. They can register for these other workshops also. In case of, even if you want to attend, again, you can attend other 2 workshops as well as if you are interested to attend again third workshop, of course, we will invite you, but your certificate will be issued for only the 1 workshop. As already Dr. Sunita communicated you, the test link will be open from 2:32 till 11 p.m. in night. So we are providing you the flexible time to attend this test. 1 attempt will be allowed. 60-minute test. There will be 50 questions, 2 marks each question. There is no negative marking. So during whole day from 2:30 onwards, anytime you can attend as per your convenience. In case you have any issue in the test, you can WhatsApp us, but request you please WhatsApp till 9 p.m. After that, if you have any problem, again, we can discuss it tomorrow. Your certificate will be issued in next week. Probably on Wednesday or Thursday, your certificate will be issued. Of course, certificate will be issued to only eligible participants as per AICTE norms, those who have attendance more than 80% or minimum 80%, and those who will score 60% and above marks, we will issue the certificate. The certificate will also show your exam test marks. Test marks we will not disclose on the public platform. It will be disclosed through the certificate also. So thank you once again to all the participants for joining this Econometrics Phase 2 STTP. And once again, I express my heartfelt gratitude to all the resource persons who have invited to all the participants. Thank you very much. Over to you, Sunita.
Dear participant, we are available on this Zoom platform next 15 minutes, and in the next 15 minutes we are going to share you this Tesmos link also. This link will be open by 2:30 p.m. to 11 p.m. Because during this test we will not be available on Zoom, so even you are facing or during exam you face any doubt, any problem, you can call us, because maybe you can you want to WhatsApp us, but due to maybe we are available on WhatsApp or not, so it's request, humble request, do not get panic due to any problem. We are available for your all solution related to your test. Okay, thank you so much. I hope this STTP has given you the great knowledge, and the whatever the knowledge and whatever the learning you have received, either with the help of theoretical aspect or and your software part, you are going to add on, or you are going to use this part in your research improvement and your research work. So overall, thank you so much again to participant. Thank you so much to my team. Thank you so much, Sachin sir. Thank you so much, Vivek sir, IBMR, IPS Academy, and AICT. So thank you so much. Now we are going to end this meeting because we have to actually organize your test also.
Participants, if you have any queries or concerns about the test, you can please ask us now. We are still available for the next 5 minutes here in the platform. I would use that time to again thank my fellow colleagues, Dr. Sunita, Dr. Tarika, and of course, Dr. Sachin Mittal sir. Without your guidance and without your constant support and the constant collaboration, everything was wonderful. So we could have achieved this. And we are again looking forward to the third phase. The second phase is over. Thank you so much, sir, for always being the guiding light for us.
Thanks to you, entire team. Dear participant, if something wrong, please share with us. And if something good, please share with others.
Yes. Share with others, definitely. The second part is because the third phase again
we will be happy for your critical reviews, critical comments.
Right now, you can share your comments with us, and if you have any queries or concerns for your test, so please talk to us now. We'll be here for 5 minutes. And after that, if you have any queries, as Dr. Sunita said, you could just WhatsApp us and we'll be there to address your queries. Right now, you can ask us in case. And it's a recommendation that you try to give the test as early as possible. Don't wait till like 11 p.m. at night. It's for your convenience that we have given so much time, but it's a good idea to attempt your test sooner. And please make sure that you very carefully write your name, because that particular your name, spelling and everything is going to go for your certificate. So good luck for your test, dear participants. And yes, we are always looking forward to such collaborations, and any questions, please ask us. The dais is open.
हेलो हेलो पल्लवी मैडम, सुनीता मैडम को सुन रहे हैं क्या?
यस सर।
हाँ सर, मैं ये पूछ रहा हूँ, जैसे जब भी मैंने टेस्ट को ऑन करा 2:30 पे जैसे ऑन होगा, मैंने 3 o'clock पे उसको ऑन किया तो 4 o'clock तक वो रन करेगा। सपोज करिए मीनवाइल यदि लाइट चले जाती है तो क्या ऑटोमेटिक सबमिट हो जाएगा या फिर मैं वापस 1 to 1 पे हो जाऊंगा?
सर आपका जितना भी एग्जाम हो जाएगा ना, वो ऑटोमेटिकली सेव हो जाएगा। और वैसे ये ऑनलाइन टेस्ट है, तो अगर लाइट चला भी गया तो भी उससे कोई प्रॉब्लम नहीं होगा।
क्योंकि शायद मैं जैसे लाइट जाएगी और आएगी तो मैं वापस उस जगह पे जब आऊंगा, लिंक पे क्लिक करूंगा, तो शायद मैं सपोज करिए जैसे 3030 नंबर के क्वेश्चन पे, तो मैं वापस वहीं पे आऊंगा 3030 नंबर के क्वेश्चन पे, या वापस फर्स्ट नंबर का क्वेश्चन ओपन होगा?
सर ऐसा होगा ही नहीं। पहली बात तो अगर आप टेस्ट दे रहे हो तो आपका टेस्ट चलता रहेगा जब तक आप उसको सबमिट नहीं करोगे ना। जितना आपका हो जाएगा उतना सेव हो जाएगा ऑटोमेटिक।
सपोज करिए जैसे 1 आवर तक 1 आवर हो गया और मैं उसके 2 मिनट ऊपर हो गया, मैं सबमिट नहीं कर पाया, तो सबमिट लेगा या नहीं लेगा?
सर ऑटोमेटिकली सबमिट हो जाएगा।
अच्छा, दिस इज वेरी गुड कि 1 आवर हुआ और वो ऑटोमेटिक सबमिट हो जाएगा। जितने भी मैंने टिक लगा रखे हैं वो सीधे सीधे सबमिट कर दिए जाए। दिस इज गुड, दिस इज गुड। थैंक यू वेरी मच।
मोस्ट वेलकम।
हलदर सर, कोशिश करना कि जब अगर लाइट जाने की प्रॉब्लम है तो फिर आप प्लीज मोबाइल के हॉटस्पॉट से कनेक्ट करके टेस्ट दो और से जल्द उन्हें सबमिट कर ही देना।
नहीं थैंक यू मैडम, ये मैं तो लैपटॉप और मोबाइल पे ही हूँ, परंतु ये मैंने इसलिए पूछा है फ्रॉम माय अदर पार्टिसिपेंट्स, अगर वो कोई बिजी हो या नहीं पूछ पा रहे हो तो मैंने उनके एंगल से भी पूछा कि हाँ आपके पास क्या इसमें ऑटोमेटिक सबमिशन है या फिर जैसे मैं रीओपन करता हूँ उसको तो मैं वहीं आऊंगा।
बट इट्स अ गुड आइडिया टू बी ऑलवेज डबल चेक एंड बी सेफ। पहले ही आप सबमिट कर दीजिए और मोबाइल हॉटस्पॉट से कनेक्ट कीजिए ताकि मतलब मोबाइल से, ताकि वो लाइट जाने की प्रॉब्लम में कोई दिक्कत ना आए।
मैं तो उसी से ही रन कर रहा हूँ, लैपटॉप भी और हॉटस्पॉट से रन कर।
गुड लक।
मेरे में क्वेश्चन आया था that what kind of the technology we are having right now. Thank you very much.
Good luck.
Okay, thank you.